Hi everyone, just before we jump into everything, I want to give you a bit of context. This is a pre-recorded class taken directly from one of my live online sessions. Especially, it is one of the sessions I run to help students prepare for the May-June exam. If you're one of those students and feel like you've missed some of the classes or you're still struggling with certain topics, don't worry, I have 4 courses available on my website that covers every topic you need to know, and you can start learning immediately. If you're in grade 12 and watching this and you're just wondering when the next round of live classes will start, they begin at the start of term 3. That's because term 2 is wrapping up and most students will be writing exams at the end of May or beginning of June. So it is perfect time to pause and then start fresh in term 3. But again, there is no need to wait. My 4 courses for grade 10, 11, and 12 are available right now, and they're designed to help you master every topic at your own pace. Now let's get into a tutorial where I'll show you how to sign up for the online classes and how to fix any issues you might run into if you already have an account. So here's a quick tutorial on how to access it. Is that first you need to make sure the fact that you're logged in, because if you're not logged in, it's not going to allow you either log in or sign up. So let me just log out so I can show you the fact that even though, let's say the fact that you are logged out, it's not going to allow you to join for free. So let's just wait for it to load. So you're going to click on join online classes. It's very important to click here. Reason for that is the free courses for each grade. That's where you're going to see it. Hope that makes sense. So you're going to click here. Then, for example, I'm going to use this May-June class. So this is for people that are writing in May-June. Obviously, when they're done with the exam, it's going to disappear. But you can pick any grade. So if you're in grade 12 or you're upgrading in November, you're going to be under grade 12, even if you're upgrading writing in November, just to say that. But if you're in grade 10 or grade 11, there is a specific course for you. As you can see, it's free, so there is no payment if you want to preview and basically see whether the online course is for you. And also it's links to get how to purchase each and every courses, because I've seen the fact that there's so many courses here. So the easiest way to get to basically see which course you want, they are all compacted in this class. Hope that makes sense. I just made it very easy for you guys. But if you want to just scroll down and see all the courses, you can do so here. As you can see, you can do so and scroll and purchase the course that you want. The nice thing is the fact that the minute you purchase, you get immediate access. But if you are struggling, I'll leave my WhatsApp number down in the description so that you basically still can purchase it if maybe you're having difficulties purchasing it online. Just wanted to say that. So I'm going to take this one as an example. So I'm going to say preview course. Then I'm going to say get course. As I said, the fact that you'll see the fact that it's going to send me to signing up first. Right? So if you say preview course and I say get, it's going to say me to signing up or sign in. With me, since I already have an account, I'm just going to sign in. But if you don't have an account, you're going to say sign up. So I'm going to sign in. As you can see, the fact that it has loaded. So after it's loaded, what I'm going to say get course. Very important to watch this video if you want to see like the downs of it and see how everything is laid out inside. You can watch this video, but I'm going to say get course. And you see the fact that when I'm saying get course, nothing is happening, but you actually enrolled. How do I see the fact that you actually enrolled? Is that if I go here and I go to enrolled courses, so if I say enrolled course, you'll see the fact that this task now is available. So if you're having problem with like seeing it, it's just say go to enrolled in your enrolled courses. You'll see it there. But if you are having any difficulties with like enrolling on your own, please, or you send me a WhatsApp. As I say, the fact that I'm going to leave my WhatsApp number below, and you're going to say start course. Then everything that is explained there is going to be here. So this is for the May-June. So a lot of things are already uploaded. But with with the grade 12 and grade 11, depending on when you're seeing this video, you're going to have material uploaded. If you're seeing it like as it's live now, then you'll see the fact that, okay, cool, things are not yet uploaded. I hope I'm making sense. So this is all the courses, so all the topics, quote unquote. So it's going to be everything. So this video explains everything. So
each and every part has a video explaining what is in each part. And as I said, the fact that going back, right, before purchasing, let's just go back to the online courses so I can make you see what I mean when we're going back, when I say joy. So what I want to say is that, do you see the fact that here, when you preview the course, this video explains everything. This video is very important. It explains everything. So I would say watch the video. So on your phone, this is how it's going to look. You just click on your icon and you're going to say enrolled courses. And this is how you're going to see your courses. Hope that makes sense. So I'm going to show you guys on how to log in because of the system temporarily is giving us problems. So I just want this to be the solution to that, right? So as you see the fact that I am logged in, right? And I'm going to log out to demonstrate this, right? So what you guys are seeing right now is that when you put in your details, which right now, because of I was logged in, it might log me back in because of I just logged in a couple of minutes. But when you sign in, is that it takes time and sometimes it doesn't load, right? As you're seeing right now, it's not loading. So this is what you guys are experiencing on your side. But I want to show you guys on actually how to fix that issue, right? And what you're going to do is that when you go to the home page, or you can go here, right? You can go here, right? When you go here, very important that when you scroll down, don't go to the home page, but click here on online courses. When you scroll down, you're going to see the different courses, right? So now the goal is to do what? Is to basically pick any one of them. I just need to emphasize the fact that the reason why you're picking one of them is not because if you want to purchase them, but it's so that you can be able to log in the system, right? So just pick anyone, right? When you pick anyone, is that obviously for you to purchase a course, you need to log in, you need to sign in, right? So you're going to just say get course, right? And when you say get course, you're going to have to put in your details. Very important when you're doing it, right? It's like, let me just emphasize again. Very important when you're picking the course, you pick the course that you're paying. Because for some weird reason, the one that is like a preview, the free one, it doesn't allow. But again, you're not going to be paying anything. I just want to emphasize on that part. You're not going to be paying anything, right? So you're going to say, what you call is get course. So when you say get course, and you're going to say get course, and you're going to have to put your login details because of you already have them, right? So you're going to say sign in, which is I'm going to be using mine. So let me just do this, right? So I'm going to say sign in. So when I say sign in, you'll see the fact that it will automatically get me back to the page. Do you see? So now, obviously, if you wanted to buy the course, you're going to say get course, but you don't need to do that anymore. You're just going to go here and you're going to say enroll courses, right? And when you go under enroll courses, you're going to see all the courses that you enrolled in. So I hope this helps, right? Because like the system problem has been like a problem lately, but I hope this helps with the system issue, right? Thank you. With that said, let's jump into the lesson. Okay. So this is last week's slides. We're finishing that. Can you guys see the slides?
Yes, ma'am.
Okay, cool. So did you guys manage to do the questions that I sent? You guys manage to do them, like answer them, because I'll be responding to them this weekend. So did you guys manage to like answer them or anything like that so that you can send them so that this weekend I can take a look at them? Did you guys manage to do that? Anyone?
Yes, ma'am.
Okay. So we're gonna finish the last question under grade 11, right? That is this question, which is this question. We're gonna finish it. Then we're gonna start with grade 12 Euclidean. Then we're gonna move to trigonometry, Anna. So that's what we're gonna be doing today. So that's what we're gonna be doing. So let me just change my pen color. Okay, it's fine. So with last week's question, let me change my color. So with last week's question is that we filled in the entire diagram, right? Then after filling in the entire diagram, let me just move this up because it's disturbing me.
Yeah. Let me do this. Right. Okay. Sorry about that. Yeah. Okay, so with last week is that we filled in the entire diagram, right? Then after filling in the entire diagram, we needed to answer the questions. As I said, the fact that it's very important for you to fill in the entire diagram because it makes it easier, né? So with last week is that when we were filling in the diagram with the first question is that we got a little bit stuck, right? And the reason why is that after analyzing it is that remember the fact that the exterior angles of a triangle, we just looked at the following, like when it's like this, right? So let me just highlight it. So we looked at when it was like this. Let me just change my highlighter because I want to emphasize. So we looked at it when it's like this, right? When the triangles are like this. And we looked at like B2 being in the exterior angle, which is going to be D2 and A1, right? We looked at it that way, but we forgot the fact that with exterior angles of a triangle, that's not the only triangles, right? The one that we wanted in this question, the relationship that we wanted, it was this one. We wanted to relate what you call this B4 with D2, right? We needed D2 inside B4. And how we could do that is this. If we use this as being the exterior angle of a triangle, right? So meaning the fact that now B4 is also equals to A1 and A2. Does that make sense? Is everyone okay with that? Hello? Is everyone okay with that?
Yes, ma'am.
Yes. So in our case is that now in triangle, and I'm going to just name the triangle. So in triangle, then this is going to be D, A, B, right? We know the following. We know the fact that angle B4 is equals to what? Angle B4 is equals to angle A1 plus angle what? Angle D2. And this is great because of, do you see the fact that we have B4 now and we have D2, right? The only one that we need is D1, right? But what do we know? And let's just write our reason. And this is going to be exterior angle of triangle, right? So now we have our D2 and we have our B4. Now we need to get rid of A1. But what do we know? We know the fact that A1, right, is equals to D1, which is great because of now we can replace it with that. But we know the fact that angle, right, D1, which is what we want, is equals to angle A1, which is what we want to get rid of, right? And this is from the notes, which is we know the fact that this is going to be what? 10 chord, right? So this is going to be the 10 chord theorem, right? So that's going to be 10 chord. Therefore, we can replace A1 by D1. So therefore, we know the fact that angle B4 is equals to angle D1, right? Plus D2, which is exactly what they want. Is everyone okay with how that question is done?
Yes, ma'am.
Yes. Any questions before I move on? Maybe you guys need some like explanation. Any questions so far? No questions. Any questions?
No, ma'am.
Okay, cool. So now we're going to move to the second one, right? Second question. And let me just do this.
Sorry, ma'am, I have a question.
Okay, cool. Okay, let me just erase something. Then you'll ask me the question, Anne. I want to erase something because this diagram is a lot is going on. So I just want to erase this. Okay. So let me enlarge
Yeah,
it.
ma'am, I just want to see. Oh, sorry.
Oh, no, it's fine. It's fine. It's fine. Let's go back to the question. Yes, listening?
Yeah, I just wanted to see how it was gonna be marked. Because I see hore there's no I see hore but again D1 is equals to A1. That's why it's replaced because it becomes what?
Okay.
It becomes time code again.
Yes.
So I just want to see how they will mark it.
Okay, cool. It's that your marks will go. Okay, so your marks, Anya. Your marks is the fact that definitely this is going to be 2 marks, right? You seeing the relationship and also giving the reason. So that's going to be your first 2 marks, Anya. Then from there is that this is going to be what? Another like mark, or this could be 1 mark, right? Then, like, let's say maybe this could be 1 mark, and I don't know where the paper is. I forgot which year it is, this one. But I think I can look, should I wait? When I submit this notes, I'll submit with the memos for it, so that you can see. But this too, it's gonna be the statement and the reason. Does that make sense? But the thing is with Euclidean is that if you just have the statement, and you don't have a reason, I don't think that they mark you the entire 2 marks, because you kind of have to say why that thing is. Does it make sense? So that is why, like in normal questions, let's go up so that I can explain what I'm saying. Do you see the fact that with this one is that when they say calculate the value of P, right? Do you see the fact that it's 2 marks? One is the value of P, and the other mark is for the statement. Does that make sense? So in this case, it's going to be the same thing as that you connecting this to saying the fact that angle B4 is equals to A1 plus plus D2, right? And you're saying the fact that that's an exterior angles of a triangle. That's going to be 2 marks because of one is a statement and the other one is the is the reason behind it. Does that make sense? And also here, what is important is that you know the fact that D1 is going to be equals to what? To A1, which is going to be another 2 marks because of now you're showing the fact that I can actually replace this 2. Do you see? I can replace this A1 by this D, which that comes from the 10 chord theorem. Then I think the final part is just you relating it back to what they want. Does that make sense? What matters here is this 2, because the conclusion is just you seeing the fact that you just substituting. So I don't think it has a mark necessarily. Does that make sense? Hello? Does that
Thank you, ma'am.
Does it make sense now?
Yes, 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 it does.
Okay. So now with that said, now we're going to move on to 9.2.2, right? So with 9.2, it says we need to prove that AGCD is a cyclic quad. So let's highlight that, right? And as I said that last week, highlights are very important, right? So they say A is here, right? Then they say G is here. Then they say C is here. Then they say what? They say D, and D is here, right? We need to prove that this is a cyclic quad. So we need to prove that this is a cyclic quad, right? So proving a cyclic quad, we have 2 properties that we can use to prove that something is a cyclic quad. One is opposite angles of a cyclic quad are what? Opposite angles of a cyclic quad are supplementary, right? Meaning they add up to 180 degrees. Or the other one is that exterior angles of a cyclic quad, right? The exterior angles of a cyclic quad are equal, right? So that's that. So now looking at our diagram, we need to basically figure out which one is easier to basically prove. Does that make sense? Is everyone okay with that?
Yes, ma'am.
Yes,
Yeah.
ma'am.
So with that said, is that we need to look at all the information and check the fact that which one will be like the easiest for us to prove, right? The opposite, the exterior angles of a cyclic quad, I don't think the fact that is going to be the easiest to prove. Reason why is that a supplementary reason why is that we don't have any values, right? And since we don't have any values, it's going to be hard for us to basically say the fact that that is the case. Does it make sense? But one thing that we can do is the following, is that we can prove that exterior angles of a cyclic quad is what? Exterior angles of a cyclic quad are are equal, right? And which one can we use? We can use the fact that if we can find that G2, right? If we can find that G2, let me just highlight it. If we can find that, let me just highlight it with a different color. If we can find that G2 is equals to D1, right, D1 and D2, then we have basically proven the fact that AGCD is a cyclic quad. Is everyone okay with that idea?
Yes, ma'am.
Okay, cool. So now let's go back to proving that, right? So we know the following, we know the following. We know the fact that let's go to G2 and link it back to where we can basically say what we're saying, So then let me put my phone on mute. right? So let's link it back. So that's going to be this. Let me take a different highlighter. We know the following. We know the fact that G2, right, is equals to B2, right? And that is going to be equals to what? That is going to be angles in the, what you call this? Angles, what you call this? This is basically going to be what? Angles in the same segment. We already stated that, right? So now we need to link it back to what? We need to link back the fact that this two, we know the fact that if this is equals to G2, what do we know about B4? We know the fact that B4, right? Where is it? We know the fact that B4 and B2 are equals to each other, right? And that is what? Vertically opposite angles, right? And then what do we know about B4? We know that B4 is equals to D1 and D2. Does that make sense? The logic. So do you see the fact that now we linked it back to the fact that these two are equals to each other? Okay? And I'm going to write it down so that it can make sense. Okay? So remember the fact that our goal is to make the fact that is to prove the fact that D1 plus D2 is equals to what? Is equals to G2, right? So let me just write it in red so that you can see the goal. As we start connecting, you know where we're going. Okay? So in red, what we want to prove, what we want to prove, is that angle G2, right, it's equals to what? It's equals to angle D1 plus D2. And that is the one that I've highlighted in blue. Is everyone okay with what we want to prove? That's what we want to prove. And through proving that, we can prove the fact that what? Exterior angles are converse exterior angles over, what you call this? Exterior angles over cyclic quad. Is everyone okay with that? With what we want to prove? Because when I start linking things, it's just going to look very foreign and I don't want to lose you guys. Is everyone okay so far?
Yes, ma'am.
Okay, cool. So now we're going to say 9.2.2, right? So now we need to link everything, right? What do we know? We know this relationship, right? We know this relationship. We know the fact that angle B2 is equals to angle G2. And what is our reason? Our reason is angles in the same segment, right? That's that, right? But what do we know about angle B2, right, and angle B4? We know the fact that they are vertically opposite angles. So what do we know? We know that angle B2 is equals to what? To angle B4. And our reason is what? Vertically opposite angles. This is here, right? This is here, right? This is vertically opposite angles, right? That's what we know. But what do we know about B4? We know that B4 is equals to what? We know, do we know about B4? We know that angle B4 is equals to angle D1 plus angle D2, right? And this was proven in number 1. This was proven in number 1, right? That was proven in number 1. But what do we know? Since everything links, do you see the fact that now we see the fact that B4 is equals to B2, right? Which is equals to, which is equals to G2. Do you see the fact that therefore that means what? That means the fact that angle G2 is also equals to angle B4. Does that make sense? Because we know the fact that angle B4 is equals to angle B2, and also angle B2 is equals to angle, G2. That means those two are equals to each other. Does that make sense? Is everyone okay with that? Is everyone
Yes,
fine
ma'am.
so far? Therefore, can we see the fact that we can conclude the fact that angle G2 is basically equals to angle D1, right? Plus angle D2. Because what do we know? We already know that angle B4 is also equals to D1 and D2. So we're replacing it with what it's equals to. So that proves what? So therefore, I hope you guys can see. Therefore, that means the fact that what? That means that A, G, C, D is a cyclic quad. Cyclic quad. And what is our reason? let me just gonna put your reason, right? Our reason here is gonna be converse. Very important when you're proving that something is a cyclic quad or parallelogram or parallel lines, whatever reasoning that you are going to use, in our case, remember the fact that we're using the fact that that's exterior angles of a cyclic quad. Since we know the fact that we've proven the fact that it's exterior angles of a cyclic quad, we're going to say converse and we're going to put that reason, right? What we just proved, so it's going to be converse exterior angles of cyclic quad. Is everyone okay so far? Any questions? Is everyone fine? Is
Yes,
everyone
ma'am.
okay? Any questions before I move to the next question? To the next before I move to the next question? No questions. All right. So let's keep this. I need to copy this. Okay. Because we need space. And let's erase this whole thing. Can we erase that? But if we need it, let's erase this. Just to, I didn't erase it. I copied the same page, so it's still up. So when I send the notes, you'll still see the solution of the first two. Just wanted to say that. Okay. So now we're moving to the last question, right? So the last question says we need to prove that DC is equals to CF. So let's highlight DC. So let's highlight DC with the different highlighter. We need to prove that DC, where's DC? DC, which is this one, right? Is equals to CF, where CF is equal to CF, which is this one. So we need to prove that these two are equal, right? How can we prove that those two are equal? Is that since this, do you see the fact that this creates like a triangle, right? Right? Since this can create a triangle like this, right? Since we know the fact that this two can create a triangle, is that what do we know? We know the fact that we need to prove those two lines are equal is that we need to prove that this one and this angle here, this angle F here, are equals to each other. And if we can prove that those two are equals to each other, therefore the two lines are equals to each other. Does that make sense? Because of that's an
Yes, ma'am.
isosceles triangle. Yes. So this is going to be 9.2.3, right? And since again is that we already proven what? We already proven the following. We have already proven, okay, cool. I have all the information that I need. So now we need to link these two together, right? So what do we know about the relationship of what you call this of F? We see the fact that angle F, right, is equals to angle, what you call this angle F is equals to angle A2. Do you guys see that? You guys see that?
Yes, ma'am.
Yes. And now, what do we see? We see again the fact that since these two are equals to each other, and again, in the previous question is that we already, from here, we already proven what? We already proven the fact that A, what you call this? A, let me just re-highlight it again, right? We already know. Let me, yeah, let me take out this. We already proven the following, right? We already proven the fact that what you call this yellow quadrant, right, is a cyclic quad. What do we see? We see the fact that we can use angles in the same segment because of that's technically a circle, right? So if we draw a circle like this, so that you guys can see it, so like this. It's not going to be a perfect circle, but just so that we know, since we proved the fact that that's a cyclic quad, that means there is a circle around it, right? Like this, right? We can prove what? We can prove the fact that angles in the same segment. So let's prove that, right? From the new information that we have. So from the new information that we have, So let's take blue. If I take this point here and this point here, right? And we see the fact that can we draw two angles from that? What do we see? We see the following. Let me take my highlighter. Is that if I go from A, I can connect to C, right? And also from G, I can connect to C, which is great. But let's see whether we can connect to another angle. So we see again the fact that from from A, right? I can connect to what? I can connect to this D angle, right? But you see the fact that from G, I cannot connect. You see the fact that there is no line that's connecting me to this D. Does that make sense? So we see the fact that there's 2 points here does not create angles in the same segment. Does that make sense? Is everyone okay with that?
Yes, ma'am.
Yes. So now we're going to move to the next 2 points, right? So my next 2 points are going to be where I'm going to be this here. So it's going to be this one and this one, right? So now let's check whether they can create 2 angles, right? So now from C, I can go to what? I can go to A, and from G, I can go to what? To A again, right? Then from here, I see the fact that from C, I can go to D, but from G, I cannot go to D, right? So that also does not create angles in the same segment. So that doesn't work again. So let's erase that. Right? Now we're going to pick another 2 points, which is going to be D and C, right? So when we pick D and C, let's check those 2 points. We see from D, we can go to A, right? And also from C, we can go to A, which is great. So now let's check from, from C, I can go to G, which is great, right? And also from D, I cannot go to G. I can go to F only. So also that one does not work, right? Those 2 points does not work, right? So my last 2 points are going to be what? Are going to be D and A, right? So we see the fact that all those points don't work. Let's check whether D and A is going to work. So from here, I see the fact that from A, I can go to what? I can go to G, right? Which is great. And also from D, I can go to what? I can go to G. From D, I can go to G, right? Then I can't go to G again. So that doesn't work too. Because I can go to G, but I cannot go to a G, but I can go to F. So that doesn't work. So we see the fact that angles in the same segment does not work there, right? Let me see from this point. Yes, it doesn't work. It also doesn't work here. And also they only can go to C like this, right? They're only gonna go to C. So that does not work, right? So that does not work. That does not work, right? So now let's see the other relationship is that we need to relate these two together, right? The only thing that we know so far, we know the fact that angle F, right, is equals to what? Angle F is equals to angle A2. So this is going to be angle A2, right? So we know the fact that these two are equals to each other. So we see the fact that angles in the same segment doesn't work. We see that these two are equals to each other and there's angles in the same segment, right? So now what do we see? We see the fact that we need to relate this two together, right? So when we relate this two together is that we see the fact that this can go here, right? And this can go here. Wait, this can go here and this can go here, but this, I don't know, I think I I don't know, but I have a feeling that the memo kind of maybe did a mistake because the thing is we cannot say the fact that those two are equals to each other because do you see what when we did the angles thing? Do you see? Let me zoom it in so that we can see it together. Because I can't say one thing then say another thing. But do you see the fact that when we're doing the angles, right? This does not make sense to say these two are equals to each other. Do you see the fact that it does not make sense to say that these two are equals to each other? because the starting point doesn't match it up. Do you see that? It's that we can go to A, but we cannot go to D. Does that make sense?
Yes, ma'am.
Yes. But according to the memo, is that they equals to each other. So I don't know. Probably there should have been a line that connects from here to there. Because that's what I'm saying, the fact that it needs to start from the same point. But what we know, the fact that this is true from, we already done in the previous video, that is true. But the other one, I don't know where does it come from, but let's do it, right? But if there is any correction, I think I'll just upload a video explaining it. But so far, what we know is the following. We know the fact that angle A2 is equals to angle F, right? And the reason is angles in the same segment, right? Right. Then, according to them, right? According to them, is that now from there we see the fact that angle A2 is equals to angle D1, right? Which is equals to angle D1, right? And that is going to be what? That is going to be, your reason is going to be what? Angle A2. So they say the fact that angle A2, right, is equals to angle D1, again, is angles in the same segment. Same segment. Angles in the same segment. Right? So that two are equals to each other. That means what? It means the fact that now angle D1, do you see the fact that now, therefore we see the fact that angle F is equals to angle D1, which is what we want. Do you see that? Angle D1 is equals to angle F, which is what we want, right? Because that creates the opposite angles of a triangle. So that is going to be equals to each other, right? That's a conclusion. So therefore, what can we conclude? We can conclude the fact that DC is equals to what? Is equals to GF, right? And the reason is what? Converse, right? And it's going to be what? Sides opposite equal, right? Then we have angles opposite equal. Does that make sense? Is everyone okay with that? Is everyone fine with that?
Yes, ma'am.
Okay, wait, I'm seeing another relationship. A2, no, it's fine. I think I'll check it out. But yeah, but that's that. This one I'll check it out. Why? Because if we're gonna use the fact that this is a cyclic quad, it does not make sense. Unless there is, yeah, no, doesn't make sense. Because that's from this yellow cyclic quad. But yeah, so that's how this question is done. Any questions on your guys' side? Any questions? Okay, I guess no questions.
May
So,
I ask,
mhm.
why is the, unless I just forgot, why is the reason like the conclusion being converse side opposite equals angles
Which
opposite
one?
equal,
Sorry.
and the last conclusion,
Yes.
yeah, D equals to GF.
Oh, why is it that? Okay, but let me draw
The reason,
the reason. Converse.
yeah, no,
Okay.
yeah, the converse side opposite.
Oh, it's that. Remember the fact that I don't need to highlight this. Okay, yeah, let me just highlight it so that you guys can see where it's coming from. So we see the fact that this is a triangle, right? So they want us to prove the fact that these two are equal, right? This line DC is equals to CF, right? Are you okay with that?
Yes.
So we see the fact that that line, those two lines comes from, if we had to highlight the whole thing, it basically creates a triangle. And what do we know about opposite sides equal, right? If we have a triangle, this creates a what? An isosceles triangle, right? Hello?
Yes, ma'am.
Yes. So now if we have isosceles triangle and they want us to prove that the opposite sides are equal, what do we have to do? We need to prove the fact that the opposite angles are equal. In our case, the opposite angles is D1 and F. Does that make sense?
Yes.
Yes. So that is why we already proved the fact that these two are equal, which is this part, right? D1 is equals to F. And now when we write the reason, the fact that this is actually a an isosceles, or the two sides are equals to each other. The reason, if we had, like, let's say that we knew the fact that this is a triangle, right? Is that from here we know the fact that we were gonna say opposite side equals slash what you call it, opposite angles equal. So we just take that reason, right? Knowing the fact that when opposite sides are equal and opposite angles are equal, we just put converse because we were trying to prove that this is technically an isosceles triangle. Does that make sense?
Okay, thank you. Yes.
Okay, cool. So that's how you would do it. So now we're going to move to grade 12's work, right? So with grade 12's work, right? So this is the proportionality theorem, right? So how do we use the proportionality theorem? So the proportionality theorem is that what we need to have is the following, is that we need to make sure the fact that M, what you call this, it says if M, so it says if MN is parallel to BC, so if MN, which is this line, right, is parallel to BC, right? They didn't talk about how this divides these two equal. They just tell us the fact that these two are parallel lines. What can we conclude? We can conclude the following. You can conclude the fact that the ratio between these two, which is M, this two, right? And divided by this one is equals to this one, right? Divided by this one. So let's start with the one that is given here, right? Is that we can conclude that BM, right, which is BM, they started from the bottom, right, divided by MA, right, which is the same thing, but they did it the inverse way, right? Starting with BM being in the denominator, which is the same thing. So we can conclude that what you call this MA, which is what you call this what you call is BM divided by what? So it's going to be BM, which is this one, divided by MA, which is this one, right? It's equals to what? We need to link it up. We started with BM. So which one is related to BM? It's this one, right? So it's equals to what? 2CN, right? Divided by what? By NA, right? And the reason for that, you're going to say proportionality theorem, and you're going to state the parallel lines. So in our case, to state the parallel lines is basically going to be proportionality theorem. Then you're going to say that MN is parallel to BC. Does that make sense? And also with this, we can also say the fact that you can change it up. So you can write it like this, or you can write it like this. You can say MA, right, divided by MB is equals to what, which is the same thing with this one, which is equals to, we started with MA, so now it's going to be AN divided by NC, right? And your reason again is going to be proportionality theorem. All right, let me just take this up. Proportionality theorem, and you're going to put your parallel lines, which is our parallel lines is going to be what? It's going to be MN, right? Is parallel to what? To BC. All right. Also, you can write it like this. Let me just write it. You can write it like this. Let me just erase this. I just want to show you all possible ways you can write it. You can start with like taking the bigger side. You can also say the fact that this is the same as, maybe let's say you have the bigger portion and the small portion, right? So you can say the fact that AC, which is this one, the bigger portion, right, divided by, maybe you have information about the top part or the bottom part. It really doesn't matter. So maybe let's say we say AN, right, is equals to, since you started with AC, who matches up with AC on the other side of the triangle is AB. So you're going to say AB right? And what did you say? You said AN, right? So this side is going to be what? It's going to be AM. And your reason is going to be the same: proportionality theorem and parallel lines, right? So same applies also. You can do the same thing. You can say AC, right, divided by maybe the bottom part, which is NC, right, is equals to AB, right, divided by what? Divided by MP, MB, right? And your reason is going to be the same. What's the one thing that you cannot do? You cannot say the fact that MN divided by what? By BC, right? And maybe link it up. You can never match this two up in terms of like this proportionality theorem. Does that make sense? You can only do the proportional of the size. Does that make sense, guys?
Yes, ma'am.
Yes. And I'm saying this because it kind of gets confusing, especially when you're reading memos, in terms of sometimes they use the down part, but they only can use the down part if we're doing what you call this, when you already proved the fact that two triangles are similar. But if we're dealing with just proportionality theorem, you cannot do that. Does that make sense, guys?
Yes, ma'am.
Okay, cool. I hope you guys are okay with that. So now let's move to a special case of what? Of proportionality theorem, which is the midpoint theorem, right? So with the midpoint theorem, what is the difference between the proportionality theorem and the midpoint theorem? The midpoint theorem, the only difference here is that, do you see this line, which is BC, right? The point here, which is P, which is in our case here, is like the similar point as M, right? Here, the point P cuts the line BC in equal parts. Let me just change my color. Cuts the line in equal parts. So this part is equals to this part. And also on the other side, this point Q cuts the line in equal parts, right? But what do they still have the same is that they still have parallel lines equals to each other. So we still have parallel lines, but the difference with the midpoint theorem is that this point here cuts the line into two equal parts. Is everyone okay with that?
Yes.
Yes. And another thing is that since this, what you call this, since we have parallel lines, which is the same as the proportionality theorem, right? And also now the only difference is this point cutting it in equal parts. We have extra properties, right? And the property is that PQ now is going to be equals to what? To a half of CD, right? Which is the same as saying the fact that CA, sorry, is equals to twice of PQ. So the bottom part now is equals to 2 times the top line. Does that make sense? So that's the two extra information, is that in midpoint theorem is that this lines on the side are cut in equal parts, and also this new information arises from that. Does that make sense?
Yes, ma'am.
Yes. And here, your reason would be what? It's going to be midpoint theorem. That's going to be your reason. So when you see the fact that it looks like a proportionality theorem, but let's say now these two are equals to each other, né? And now, since these two are equals to each other, right? Now we can conclude this two is going to be half of the other one, right? If you see that situation, you shouldn't say a proportionality theorem, but you should say what? Midpoint theorem. Is everyone okay with that? What is the difference between the proportionality theorem and the midpoint? It's just a special case of the proportionality theorem. Is everyone okay with that?
Yes, ma'am. Ma'am, can I ask a question?
Mm-hmm.
So BP and PC are equal, and on the other side, but all four of them are not equal
Oh,
with
no,
each
no, no,
other.
not, yeah, on each side. I'm sorry.
Okay.
Okay, it's like this. Yeah. Is everyone okay? Thank you for that.
Yes, ma'am.
Okay, any questions with the midpoint theorem? Any questions? Okay, I guess there's no questions. So now we're gonna move to proving similarity, what you call it, similar triangles, right? So with proving similar triangles is the following: is that there's two ways you can prove that two triangles are similar. The first case is when you're proving that. Let me just change my pen. The first case is proving that all angles are equals to each other. So as we, from the diagram, we see the fact that angle A is equals to angle D, angle B is equals to angle E, angle C is equals to angle F. And if you can prove that all angles are equals to each other, then we can say the fact that triangle ABC is similar to triangle DEF, right? And your reason for that will be what? Will be angle, angle, angle. So this is going to be your reason. Does that make sense?
Yes.
Then the second one is when we proving that what you call this two triangles are similar. What do we use there? We're gonna use the following, which is gonna be proving the fact that all the angles are in proportion. So in this case is that if I can prove that MN, right, divided by what? MN divided by, let's see here, we see the fact that we're proving that MN, right, divided by Z, by Z, what you call this, by XZ, right? If I can prove that this two is equals to, now let's find another pair, right? Which is in our case, is going to be ML, right? And again, we're going to have ZY, right? So let's do double tick there. If we can prove that, right? So when you punch this into the calculator and the last one, which is ML, which is 3 ticks, right, is equals to what? To this one, right? If let's say I punch this, we already know from here, we have the fact that MN is 12. So this is going to be 12 divided by what? Divided by 18, right? Do you see the fact that this is 12 and this is 18? We see again, we have a 12 and 18. Do you see that? We have 12 and 18. And we also see the fact that we have 12 and 18. Do you see the fact that all of them are equals to 12 and 18? Sorry, 12 and 18. So since they all equal, since all their ratio are equals to 12 and 18, right? That means the fact that the triangles are what? Are similar. And the reason for that is going to be side, side, side. The side, side, side does not mean the fact that the two triangles are like, it does not mean the fact that the sides are equals to each other. But in similarity, it means the fact that the sides are what? Are in proportion with each other. I hope that makes sense. In what you call this, incongruency, right? It means the fact that the sides are equals to each other, but in similarity, it means the fact that the sides are in proportion with each other. Does that make sense?
Yes, ma'am.
Is everyone okay with that?
Yes.
Any questions? Okay, I guess no questions. Any questions before I move to actual questions? To a question from a past paper? Any question? Yeah, I guess no question. So now let's move to, this is a proof, so let's move to an actual past paper question, Anna. So with the past paper question, it says in the diagram below, a cyclic quad E, so they tell us the fact that a cyclic quad, let's highlight that cyclic quad. So they tell us that a cyclic quad E, right, EF, so we have EF, then we have G and H, right? So this is a cyclic quad. They tell us the fact that this is a cyclic quad, right, is drawn. So since we know the fact that this is a cyclic quad, we have to put in properties that are related to cyclic quad. So let's do that. Remember the fact that it's very important to fill in all the information that you have, right? So let's start with the cyclic quad. Let me change it to green. So we have cyclic quad. So we're going to put cyclic quad here. So what do we see? We see the fact that since this is a cyclic quad, we see the fact that we have exterior angles of a cyclic quad, right? So we see the fact that angle H2, right, is going to be equals to angle F. That's exterior angles of a cyclic quad. Do you guys agree? So angle H2 is equals to angle F. Is everyone okay with that? And your reason is going to be exterior angle of cyclic quad. Is everyone okay with that? Is everyone okay with that?
Yes, ma'am.
Okay. Then we also see the fact that G3 is equals to what? To angle E, right? And again, that's exterior angle of a cyclic quad. So let's do that. So angle G3 is equals to angle E, right? And again, the reason is exterior angle of a cyclic quad, right? And we see the fact that in our case, that is the two that we can like put in terms of information wise, because if there isn't any angles or any variables, right? So that is the information that we can put, right? So that's that. Then they tell us the fact that we have a chord. They say the fact that our chord CH, so we have a chord CH, we have a chord C, where's C? So let me just erase this because we have put in the information. Let me just emphasize who's equals to. This is going to be double lines. So you can see who is who, right? So tell us the fact that we have a chord E, H, right? So we see the fact that that is a chord, and another chord which is FG. So another chord which is FG, right, are produced to meet at K. So they tell us the fact that those two chords extend to meet at J. At K, so they tell us the fact that M is a point on EF. So they tell us that M is a point on E, what you call this, on EF, which is we can see. And also they tell us the following information that MG is parallel. So they tell us that MG, so let me just erase this. Okay. So they tell us the next couple of effects. Let me just with this one, so we can know who relates to that, right? The fact that that is a cyclic quad. Then they tell us the following information that MG is parallel to what? MG is parallel to EF. So we see the fact that MG, which is this one, right, is parallel to what? To this one, right? So now we need to basically talk about the properties of what? Of a cyclic quad, or what you call the properties of a parallel line, right? So let's do that. So let's take our pen, change the color into being this one, and I'm just going to say parallel lines. Right? So what do we know about the parallel lines? Do you see the fact that here we can create an F? You see the fact that here we can create an F. So let's take our highlighter. Do you see the fact that we can create an F here, right? Since we can create an F, what do we see? We see the fact that this angle here, E, is also equals to angle M1, right? So we see the fact that angle E is equals to angle M1, right? And what's our reason? Corresponding angles. Those corresponding angles, right? So it's corresponding angles, not of what? Of nothing. Sorry about that. So it's going to be corresponding angles. Then you're going to put your parallel lines, right? So you're going to put your parallel lines. What are your parallel lines? It's the fact that we know the fact that EH, right, is parallel to what? EK, sorry. EH or EK doesn't matter, right? So EK is parallel to MG. Is everyone okay with that? Is everyone fine with that? Any questions so far? And we see from the parallel lines, any questions? Any questions, guys? Any questions? No questions? Okay. And we also see, before I move to the last part of the statement, and we also see one more thing. We see the fact that the only visible property that we can use is the corresponding, but there's no alternating because there's no Z. And also, it really doesn't matter to use co-interior because there isn't any valuable, like, what you call this, numbers. So it's going to be like a little bit pointless to use that, right? So these are the two properties that you have, right? Then the last statement, right?
May I ask?
Yes, listening.
So we only use criteria when they are variables,
No.
unless
Yeah,
the question asks.
unless the question, unless you can unless in that question you can put in the relationship together. Because the thing is with cointerior, remember the fact that it says the fact that with cointerior angles is that we know the fact that in this case it's going to be that G2, for instance. Let me just do this. We know the fact that maybe, let me change my color, I'll change it back. But with cointerior, right, we know the fact that it basically says the fact that the angle G2, right, and angle, what you call this, angle M2 plus angle E, right, is equals to 180 degrees, right? And since we know the fact that this is the relationship, this is going to be cointerior, right? So since we do not have any variable, right? Since we do not have any variable, is that, let's say we had the variables and we already know what's E. Do you see the fact that we can use this relationship to basically find M2? Because we can, through this relationship, we can calculate what is the angle of M2. Does that make sense? Why I say the fact that it's nicer if you have variables to use that property. Does that make sense?
Yes, ma'am.
Or I think another question, let me just go back. Another question that we used it is that when we wanted to prove that something is a cyclic quad, right? Yeah, I think it's this one. Yes. Do you see the fact that here we wanted to prove the fact that this yellow cyclic quad is actually a cyclic quad, right? And we use that relationship of parallel lines. Do you see that? We see the fact that AB is parallel to DE, right? And what do we know if we wanted to prove that something is a cyclic quad? What do we know about that? We know the fact that since this whole thing was X, right? We had like this relationship of basically figuring out the fact that this angle here is 180 minus X, right? And that is from where? From the relationship of the relationship of the parallel lines. Does that make sense? Then from the relationship of the parallel lines, we could go back to proving the fact that if we add these two together, right? If we add these two together, we know the fact that we're going to get 180, which we can prove the fact that opposite angles of a cyclic quad are supplementary. Does that make sense? So it
Yes, ma'am.
depends on what you're using. Are you fine with that?
Yes, ma'am. Thank you.
Yeah. So, but it's very good to keep it at the back of your mind, the fact that like that relationship exists. Okay? So let me take my eraser. So now, is anyone asking a question?
Yes, ma'am.
Yes.
Is H2 not equal to G2 because of alternative angles?
Wait, H2. So you're saying the fact that isn't it H2? Let me see. H2 equals to?
G2.
Yeah, let me see. Oh no, it's not. It's not. And the reason is this. Do you see the fact that yes, we can extend this line, right? Because that's the whole line. That's parallel. Does that make sense? We can extend that, but wait, I think you're right. So then this one, let me see. Let me see whether we can. H2 equals to G2. I think you could be right. It doesn't look like a proper Z, but it makes sense. Yeah, I think you're right. I think you're right. The fact that H2 is equals to G2, and that is alternating angles. Thank you for that. Yeah, so angle H2, right, is equals to angle G2. G2, and the reason is alternating angles. Is everyone okay with that? And the parallel lines. I'm just going to put lines. Is everyone okay with that?
Yes, ma'am.
Okay. Any questions so far? Let me just do this. And let me put this down. Let me highlight this. Okay. So with that said
Ma'am,
now, mm-hmm.
isn't E alternating angles? Shouldn't the alternating angles be equal to that or and
Okay, yes, but that's what I'm saying, the fact that normally it's like it's tilted. But if we had to extend, because the reason why I'm saying she's correct is that if we had to extend this line, do you see? If we had to extend it, because they didn't extend it, is that creates two parallel lines again, right? And we can create a Z, whether that Z looks like a good Z. So from there, let me just take my highlighter again, is that from there we have two parallel lines, which is what we need, right? And now this one is extended. Do you see that? And now the goal is that if you can create a Z, right? So in this case is that our Z, our line is not slanted like that, but it's like kind of like straight or like a little bit tilted. Do you see? So, but we can still create a Z. Do you see that? We can still create a Z like if you do this. Do you see that? You can still create that relationship. Does that make sense?
yes, ma'am.
Yeah. So that is why I agreed with like it being equals to each other. The angles being equals to each other. Any questions? Any questions, guys? Any questions? No questions. Okay, I guess there's no questions. Okay, so since there is no questions, we can go to answering the questions. But before we go, no, we have one more statement and two more statements that I want to add on top of that. But the last statement, let me just erase this, right? Now, the last statement is the fact that they tell us the fact that, let me just take my highlighter. They tell me the fact that D, what you call this, KG, where's KG? KG is this one, right? Is equals to M E, sorry, in my alphabet, E, F, right? They tell us that the two lines are equal to each other. So there's nothing special about it. They just tell us the fact that those two are equals to each other. Those lines are just equals to each other. And so they just tell us that. So another thing that you need to see is the following, is that since this is two parallel lines, right? We have two parallel lines. You need to see this relationship. Do you see the fact that proportionality theorem also is here? Since this line here, do you see? This line here, purple line, is parallel to this line. Do you see the fact that we have a triangle? Do you see the fact that we have a triangle? And you see the fact that since these two are parallel to each other, that we can use proportionality theorem here. Does that make sense? Do you guys see that? You guys
Yes,
see
ma'am.
that? Yes. Just wanted to show you that, right? But let's just take it out because since that is the case, chances are it might play a role in one of our questions, Anna. So let me just highlight this. Yeah, so re-highlight that, right? So now for answering questions, let's go to a new page. Let me go take my questions. So now let's answer the questions on it. So the first one says the fact that we need to prove that we need to prove that triangle KGH is similar. Remember that when it's looking up, it means the fact that we're proving similarity to triangle KEF, right? So let's highlight both those triangles that we need to prove. So let's highlight the first triangle in yellow. So we need to, prove that triangle K, right, G, right, and H, right? So we need to prove that there are two. So let's highlight that triangle. Right? Is what is similar to triangle K, right? K again, we're gonna start here. So let's take another color. Orange. So K, right? And let's just take a bolder color, green, right? So K, right? Then it's gonna be E, which is gonna be here. E, then the last one is going to be F. So it's going to be, so it's the triangle that's inside the small triangle. Does that make sense? So we're proving that the top triangle here is E is similar to the smaller one that's inside. Is everyone okay with that?
Yes, ma'am.
So now we need to prove that. So now we're going to go to 10.2.1, right? So we're going to say A, right? So we're going to say in, because that's the two triangles. So you're going to just write it the way it is. So in triangle, K, GH, GH, right? And the other triangle, which is K, E, F, right? So we need to prove that the two is equals to each other. The first thing that we see the fact that K is common throughout both of them, right? So the first statement is that going to be angle A. And remember the fact that when you're proving similarity and congruence, you need 3 statements in total. So we're going to have the following is that this K angle here, right? This angle K is common, right? So we know the fact that angle K is common, right? So that's the first statement, which is we can see that it's common. Then the second statement, right, is that what do we see? We see the fact that we already proven that angle, which equals H2, which is in the yellow triangle, is equals to angle F, right, which is in the bigger triangle, right? And that was what? That was exterior angles of a triangle, which was exterior angles of a cyclic quad, right? So we know the following. We know the fact that angle H2 is equals to angle F. And our reason is exterior angle of cyclic quad. Is everyone okay with that?
Yes, ma'am.
Yes. Then what do we see? We see again, we're going to use exterior angles of a cyclic quad, but because we already proven that angle G3 is equals to this angle. So G3 is in the small triangle, but that is equals to angle E, which is in the bigger triangle, and there's also exterior angles of a cyclic quad. So you can say number 3, angle G3 is equals to angle E, and our reason is going to be exterior angles of a cyclic quad. Okay, I want to give you guys one more tip, right? Let's say when proving, especially when you're dealing with like maybe the ones that you're proving is the angles, right? And let's say the fact that you found 2 angles, right? By default, you can conclude that the last 2 angles, like let's say you have what? You have like this 2, you've proven that these 2 are equals to each other, right? You have 2 statements and both of them are angles, right? In similarities. Is that with this one, you can automatically conclude the fact that that is going to be equals to each other. And your reason, with our case, it was exterior angles of a cyclic quad, but your reason here could also be sum of angles in a triangle. Does that make sense why we can conclude that? Should I explain why we can conclude that so that you can understand it?
Yes, ma'am.
Should I explain it?
Yes, ma'am.
Okay, cool. So let's say, and I'm going to just rewrite the triangles, right? So let's say we have this triangle, which is the small one, right? And the small one is what? It's KGH, right? It's KGH, right? And we have a bigger triangle. And the bigger triangle is what? Is K. And this is going to be KE, who matches up with H. It's KGH. So H matches up with F, right? So F is going to be here. Then this matches up with G, and G matches up with E. Yeah. Yes. K, what you call this, KEF, right? So with these two, I'm going to name them in alphabets, right? So what do we know? We know the fact that these two are equal. So let's say this is angle A and angle A, right? And what do we know? Again, we have proven from what we have is that we know the fact that these two are equals to each other, right? What do we know? We know the fact that sum of angles over triangles are equals to what? Are equals to 180. So from that information, if it was in terms of variables, do you see the fact that I can find the sum, which is in our case is that angle K plus angle G plus angle H, right, is equals to 180 degrees, right? So what do we know? The fact that this is A, this is plus B, and this is going to be G, sorry, and this is going to be plus B is equals to 180 degrees, right? So do you agree the fact that this is going to be that angle G is equals to 180 degrees minus A minus B, right? So this is going to be the same as what? This angle here. Let me just write it here. It's going to be 180 degrees minus A minus B, right? Also here, when we calculate angle E, finding the sum of angles of a triangle of this one, right, is going to be angle K plus angle F plus angle E, right? And that's going to be equals to 180 degrees. We already know that K is A. We already know that B is this one. And we already know the fact that we're looking for E, right? So this is going to be angle E is equals to what? To 180 degrees minus A minus B. Do you see the fact that both angle E and angle G are going to be equals to each other? And both of them is because of sum of angles in a triangle. Does it make sense? Does that make sense, guys?
Yes, ma'am.
So that is why, even if, let's say, we didn't have this reason, you can so much just conclude the fact that if we have two angles, right, we can just conclude the fact that the last two angles are equals to each other. And the reason for that is going to be sum of angles in a triangle. That's fine, right? So if that's it, I can erase this. I'm just going to leave this one with the first reasoning. But just know that you can use the second reason, right? So with that, we can conclude that, therefore, the triangles that we want, which is triangle KGH, is similar to triangle KEF. And the reason for that is going to be angle, angle, angle. Is everyone fine with that? And that is, yes, I'm listening.
When you're proving a similarity, it isn't gonna be Ilenduza, like at the end, angle.
Yes, if you prove that the angles are equals to each other. But if you prove the fact that the angles are similar to each other, like are in proportion, sorry, if you prove the fact that the sides are in proportion, very, very important, not equal, but in proportion with each other, then your reason is going to be side, side, side. Does that make sense?
Yes, ma'am.
Okay, cool. So that's that. So is everyone okay with this question?
Yes,
Yes.
ma'am.
Okay, cool. So that's that. Let me erase this because we're gonna need to highlight. Okay. So the next question, it says, let me take my highlighter. It says we need to prove that EF squared is equals to KE multiplied by GH. So when proving this type of question, I like going back to the diagram and checking what they want from me, right? So let's highlight what they want from me. So in our case, they say we need to prove that EF squared. So we need to prove that this whole thing, right? So this side, in terms of the question, is there, right? And they also told me the fact that KE, where's KE? KE, K, and E is here. So this whole thing here, right? Multiplied by, so this one is going to be multiplied by GH. So it's GH, so G, right? And H is this one. It's this one. So what do we see? We see the fact that all the sides that they're talking about is from the side GH is from the small triangle that we proved. Do you see that? This GH is from the small triangle that we proved. Then do you see the fact that EF is from where? It's from the big triangle that we proved, and also the fact that EK is from what? It's from the big triangle that we proved. And do we see, remember the relationship that we have, the fact that EF is equals to GA to GK, which is that is from the small triangle. So to prove this, we're going to have to use what? We're going to use, we have to use the two triangles that we proved, right? We need to use this condition to prove the fact that this can happen. Does that make sense? Does that make sense, guys? I hope I didn't confuse you. Does that make sense? Why we're going to be using, in terms of using similarity in this case, we're going to use the triangles instead of the parallel lines, because of all the information that we want is from the big and small triangle. Does that make sense, guys? Does that make sense? Hello?
Yes, ma'am.
Yes. So with that said, is that I like taking out the two triangles from the diagram and sketching them on the side so that I can see who matches with what, right? So let's sketch the small triangle. So for 10.2.2, right, B. As I said, I like sketching it out. So we're going to have the small triangle, which is going to be the upper part, right? Which is that triangle in our case is going to be K. Very important when you sketch the triangles, you match up the angles with each other, right? So we see the fact that angle K, then we have G, right? GH, right? So we're going to match it up with the bigger triangle, right? Which is angle K, right? So let's just match it up, which is EF. It really doesn't matter. What matters is when you're writing the angles, right? They need to match up. We see the fact that those two are equals to each other, and we know the fact that that's common. But we see the fact that from the small triangle, which is going to be H2, let me just do it like this, cross like this, right? So we can see the fact that there's a different angle. We know the fact that H2 from here, which is going to be this H, matches up with what? Matches up with F. So this is going to be a like that, right? Then we see the fact that by default that G, which is I'm going to put it as a tick, they matches up with each other. That's very important because of when you're doing similarity, right? That's going to matter, right? So now I'm going to highlight the information that we have here. The one in green, I'm going to highlight it here, right? So we see the fact that from the question, let me erase that, right? We see from the question, we have what the following sides. We see the fact that angle, they said the angle EF, where's EF? EF is here, right? EF, right? EF, that EF, then they said the K, which colors? Let's do it in different colors so that it makes sense. So, no, let's just do it in one color. It really doesn't matter, right? So we know the fact that it's going to be EF, right? And EF, and then here we have KE. So KE is going to be this side here, right? And we have GH, which is going to be this one, right? So our question, sorry about that. Let me take some water. So another thing is that we know the following information. We know the fact that EF, right? So EF, where's EF? EF, which is this one, is equals to which side? To GK. So GK. So these two are equals to each other. Is everyone okay on how to basically replicate the triangles and make them side by side? Is everyone okay with that?
Yes.
Yes. So
Yes, ma'am.
Okay, so now with that said, now we can answer the question. We're going to go back and see how it's written. We see the fact that they start with what? With EF, right? So we're going to start with EF and relate it to the other side where EF is equals to what, right? So we see the fact that we need to start with EF because that is the subject of the what? That is subject of the equation, right? We see the fact that EF, right? EF on this is on the big triangle, right? EF is related to what in the small triangle. Do you see the fact that we have an X and a tick, and here we have an X and a tick? We see the fact that EF is related to what? To GH. Is everyone okay with that? Does everyone agree with me? Because of also on the side, okay, so we have an X and a tick, right? And that is going to be equals to what? We're going to match it up on the big triangle, the other side that we highlighted. What did we highlight? We highlighted the fact that KE, right? What is KE related to? In our case, KE is related to this side, right? Which is a dot and a tick, which is a dot and a tick on the small triangle is what? Is KG. Is everyone okay with that?
Yes, ma'am.
And our reason here, since we're using triangles, we're going to say what? This reasoning. We're going to say that because of triangle KGH is similar to triangle KEF. Is everyone fine with that?
Yes, ma'am.
Yes. So now we're going to cross multiply, right? Because of, in this case, it's multiplication. We're going to cross multiply. So we're going to cross multiply. So it's going to be EF multiplied by KG, which is going to be equals to GH multiplied by what? Multiplied by KE. Do you see the fact that now we have this side? This side is sorted. Do you see that? We have GH and KE, which is great, right? Now we need to sort out this side, right? But we know the following. But we know the fact that what? We know the fact that EF, right, is equals to KG, right? So we can replace KG by EF. So therefore, we see the fact that we're going to have EF multiplied by another EF is equals to what? Is equals to KE multiplied by GH. Is everyone okay with that? Is everyone?
Yes, ma'am.
Yes. So therefore, do you see the fact that we're going to have what they want, which is EF squared is equals to KE multiplied by GH. So that's how you would answer this question. Is everyone fine with that?
Yes, ma'am.
Yes. So just remember the fact that you always have to basically look at the information that you're given and link it back on how we can come back to the answer that they want. So that's how you would answer this question. So let me just do this because we need space. Copy this. And erase this whole thing. So we can have space. I think after this question, before we start trigonometry, we can have like a cute 10 minutes break. Then we can start with trig. And let's just finish up this one. Yes, right. So the next question, let me take my highlighter. The next question says the fact that we need to prove that KG is equals to EM multiplied by KF. So again, it's very important to see which one we're going to use. And the reason why I'm doing this is to see the fact that here we can use two types of proportionality theorem, right? We can use the similarity, which is what we used here, or we can use the proportionality theorem, which is related to the parallel lines. Do you guys see why I highlight which one is which, right? So in our case, let's see what they want, Donna. So we see the fact that they're talking about kg. Where's kg? Kg is this one, right? So we see the fact that we have kg, right? So we have kg squared, right? So meaning if it's kg squared, meaning by default, EF is going to be related there. Does that make sense? Because the only way to get this squared is that this relationship needs to be there. Does that make sense, guys?
Yes, ma'am.
Yes. Then we see the fact that we have EM. Where's EM? So we have EM, which is this one, right? And we have KF. So it's KF. So KF is this one, this whole big one. Do you see the fact that here, the sides that we're talking about is from what? Is from this big triangles and the parallel lines, right? And I'm just going to basically redraw the triangle here. Let me just change my pen. Because if it's upside down, redraw it like this so that you guys can see it. Right? So here at top, we have F, right? We have F, then the two parallel lines here. So this is going to be F, and this side is going to be, let me just say, this is going to be M, and this is going to be G, right? And this one is going to be E, and this one is going to be what? And this one is going to be K. And we have the two parallel lines. So do you see the fact that all the information, they didn't include this GH. So meaning all the information is within this triangle, right? Because what they want here is that they wanted this portion, and I'm just going to do it in curved brackets. They talked about what you call this KG. KG is this one, right? KG, wait, it's K, and G. They talked about this one. Do you see? They talk about that one. Then then another one is going to be what? It's going to be EM. So EM is going to be what? EM is going to be this one. Right? And you see the fact that already those two are related. Does that make sense? Already those two are related. Then the other one, which is K, what you call this? KF, which is going to be this big one. Right? It's going to be this big one. So with that said, again, is that we need to basically put in the two equal sides, right? What do we know? We know the fact that EF, which is EF, right? And I'm just going to highlight it here so that you can see it. We know the fact that EF, which is this side here, is equals to what? Is equals to GK, right? Is equals to this side here. Does that make sense? Is everyone okay so far?
Yes, ma'am.
Yes. So do you see the fact that every information in terms of C is contained within this, what you call this, big triangles with parallel lines, right? So this is going to be 10.2.1C, right? So with that said, is that we're going to follow what they written it. We're going to start with KG, right? So we're going to start with KG. So we know the fact that KG is related to what? KG, do you see the fact that it's related to ME? So we see the fact that KG is divided by ME, right? Then what do we have? We have the bigger side, right? Which is in our case is going to be what? It's going to be FK, right? So it's going to be KF. So it's going to be KF, right? And KF is going to be related on the other side, the bigger side, right? The bigger side, which is FE. FE. Is everyone okay with how I did this proportional?
Yes, ma'am.
Yes. And our reason here is going to be what? Proportionality theorem. It's going to be proportionality theorem. Then put your parallel lines. Just make it a habit of putting parallel lines because sometimes you might be dealing with more than two parallel lines, right? So it's going to be MG is parallel to EK. Now, since that is great, now we can cross multiply because of here it's cross multiplication. So we're going to cross multiply. So we see the fact that KG, right, multiplied by FE is equals to what? Is equals to EM multiplied by KF, which is exactly, now on the other side, we have exactly this, right? Which is great, right? But now we need to sort out this. But what do we know? We know the fact that, what you call this? We know the fact that KG, right, is equals to what? To FE, right? But we know the fact that KG is equals to FE. So I'm going to replace the FE now. So when I replace it, it's going to be KG multiplied by KG is equals to EM multiplied by KF, right? So this is going to be the same as KG squared is equals to EM multiplied by KF, right? Which is exactly what you want. Does that make sense?
Yes, ma'am.
Yes. So that's how you would do this one. Nane? So now moving on to the last one. Nane? So the last one is that it tells us the fact that if you're given that KE, so it's KE, so let me just okay. So they tell us the fact that if we have the following, if we have that KE, so KE, which is the whole big part, right? KE, so it's this whole thing, right? They tell us the fact that if we know the fact that KE, no, I lied. K is not that one. KE is the base in our case. So KE, which is the base here, right? So it's the whole part here, which is the base here, is equals to 20 units, right? And they tell us the fact that KF, so this whole thing, let's write it here so it can make sense. This is equals to 20 units, right? And they tell us the fact that KF, right? KF, which is this one, right, is equals to 16 units. And they tell us the fact that GH, which is this one, is equals to 4 units, right? And they tell us the fact that we need to calculate what? We need to calculate the length of EM. So we need to calculate this one. This is what we need to calculate. What do we see? We see the fact that from the units that they gave us the units from where? The units from both the big triangle, which deals with parallel lines, and also some of the information, and that information is this GH means the fact that they also use the proportionality theorem. But let's link down this two. Do you see the fact that there's two here? This KE, do you see the fact that this KE is here? Do you see that? This KE is there, right? We see the fact that this KF is this one, right? Do you see? Let me just do this. Let's just do it in the highlighter so that you can see. Okay, let's do it in highlighter. I want you guys to see this, right? We see the fact that since both information are both in the triangles, like in terms of similarity, and how do we know the fact that is that because of this GH, right? This GH tells us the fact that we can't just use the proportionality theorem because we cannot cut half of the some of the information are from the similarity. Is everyone okay with what I'm saying? Is everyone
No,
saying?
ma'am.
Sorry, you guys are
No,
not.
ma'am.
Are you understanding?
No.
Okay, cool. So is that, do you see the fact that when we were dealing with when we were dealing with this similarity, right? What actually told us the fact that when we doing the proportionality theorem, right, we're gonna use similarity triangle is this line here. Let me just highlight it. Do you see this line here? This one basically tells us the fact that the only relationship that GH can have is with this one, with EF, right? With EF. And the reason for that, what you call as GH is EF, the reason for that is because of this reasoning. Does that make sense? That's the only way those two can have a relationship together. Does it make sense?
Yes, ma'am.
Yes. So with that said, is that in this case here, right, is that our variables, do you see the fact that the variable numbers is that half is from the similarity situation and half is from the parallel. So we kind of need to use both the similarity and parallel to basically solve for whatever unit they want. So that is what I'm saying here. Some of the information, this one tells me the fact that I kind of need to use my similarity, and also the 16, do you see the fact that this EF and also this what you call this EK and this EM especially in this case, do you see the fact that this EM tells us the fact that in this case now, with this EM, tells us the fact that in this case, we kind of need to use the parallel lines, because where can we find the relationship with EM? It's within the parallel lines. Does that make sense? Because if we had to do the triangles, this triangle, we can't cut it in half. Doesn't make sense.
Yes, ma'am.
Yes. So that is why I'm saying the fact that both information comes from the similarity, what we have proven here, right? And the other one comes from parallel, and we kind of need to link them together, right? So now with that said, the fact that we kind of need to use both properties to calculate the last question, let's what is the two things that can link them together? Let's see whether the variables that are given here at the bottom can be the ones that we solved in B and C, right? Because remember the fact that B is related to the similarity triangle and C is related to what? Is related to the parallel one, the parallel lines. Does that make sense? Why I'm linking B and C together? Because one is from similarity and one is from parallel. Does that make sense?
Yes, ma'am.
Okay, cool. So with that said, now let's link them together. Is that we see the fact that we have KE. KE comes from what? We see it here at this one, right? We see it here at B, which is we have KE, which is 20 units, right? And we also see the fact that we have a KF. KF is here. Do you see that? So we see the fact that, okay, one comes from the similarity and the other one comes from the what? Comes from the parallel lines, right? Then we see the fact that we have GH. So we see the fact that we have GH. GH is at similarity. Then what we want to calculate, and I'm going to highlight in red, right? What we want to calculate is going to be this EM. And this EM comes from what? Comes from the parallel. So this is great. Why is this great? Remember one property. Okay, cool. Why is this great? Do you remember the fact that we already established the fact that EF, right? We already established that EF, which is this one, right, is equals to KG, which is this one. And they both squared. Do you see the fact that we can equate those two together, right? Because, so let me just do this. So 10.2.2, right? So we established the fact that everything, the variables are the ones in yellow, right? And the red is the one is what? Is the one that we want is in red, right? We established the fact that the variables is the three unknowns, so we can calculate this. But what do we know? We know the following. We already know the fact that EF, right, is equals to what? Is equals to KG, right? And also, if we square both sides, that means the fact that EF squared, right, is equals to KG squared. Does that make sense? So those two are equals to each other. Does that make sense, guys?
Yes, ma'am.
Yes.
Yes. So now what we're going to do is that at EF squared, we're going to substitute by this. So we know the fact that KE multiplied by GH is equals to what? To EM multiplied by E by KF. Sorry, by KF. Is everyone okay with that?
Yes, ma'am.
Now we can substitute all the variables. You'll see the fact that what we want is going to be the one that's unknown, right? So we see the fact that KE is 20 multiplied by what? Multiplied by GF, which is 4, right? It's equals to what? So let me do this. This is going to be EM, which is what we want, multiplied by what? By KF, which is KF is 16. Right? So now we're going to take the 16 to the other side. So this is going to be the same as 20 multiplied by 4 divided by 16 is equals to EM, right? Punch that to the calculator, right? When you punch that to the calculator, you're going to find the fact that EM, so we're going to find the fact that therefore EM is going to be equals to 5 units. Is everyone okay with that?
Yes, ma'am.
Yes, ma'am.
Any questions? Any questions? Any questions before we take our break? You guys have any questions? Okay, so just want to emphasize is that you see the fact that with this one, it's very important to highlight what you need. And by us highlighting what we need, it makes it easy to know whether to use similarity or to use the parallel lines as our reason in terms of proportionality, right? Is everyone okay?
Yes, ma'am.
Okay, cool. So with that said, let's take our break. I'll make it 10 minutes so that you guys can take a breather. Then we'll come back at 25 plus 8. Then we'll do trigonometry, Anna.
Yes, ma'am.
Yes, ma'am.
Okay, cool. Is everyone back? Is everyone back?
Yes, ma'am.
Okay. Let's wait another minute or so to wait for other people to come back. Okay, so now we're going to do trigonometry. Let's hope the fact that we can do it till like 9:30, but I don't think we might finish everything. But my goal is to finish everything today in terms of trigonometry, but I'm just looking at the fact that our class is going to end at 9:30. So we have an hour, okay, and a couple of minutes. So now we're going to do trigonometry, right? So with trigonometry, the first question that we're going to do is related to a Cartesian plane, right? So it says if A is, let me just move this because it's telling me, right? It says if A is equals to 3/5, and they tell us another extra information, which is cos A is greater than 0, is less than 0, right? That cos A is less than 0, then they say without a use of a calculator, we need to determine the following, right? So with this question, we need to use the Cartesian plane, right? So we have to use the Cartesian plane, and you will understand why the second condition is there, right? So let me just change my pen. So for the first thing is that we need to draw a Cartesian plane. So I'm going to draw a Cartesian plane like this, right? And we're going to state the following, which is all students take coffee, right? So they tell us the fact that they give us this information, which is sine A is equals to 3/5, right? What matters here is to know where we're going to draw the triangle. What matters is that we need to ask ourselves, where is sine positive? Because 3/5 is positive, right? So we see the fact that sine is going to be positive in the first quadrant, and also it's going to be positive on the what? It's going to be positive on the second quadrant, right? So we see the fact that,
Ma'am,
yes,
I don't see the trig, what you're doing
really,
now.
really. Okay, cool.
Yes.
Oh, let me reshare. I think I'm still sharing the Euclidean, right?
Yes, ma'am.
Okay, let me stop this and let me reshare it. Trig. Okay, I'll explain again. Does everyone see the trigonometry notes? Can you guys see the trig notes?
Yes, ma'am.
Okay, cool. So let me just
Yes,
erase
ma'am.
this. Okay, let me just erase this and start all over again. Okay, let me do this because so as so this question is going to be related with the Cartesian plane, right? So with the Cartesian plane, it says if sine A is equals to 3/5, and they tell us another condition that cos A is less than 0, then they say determine without a use of a calculator the values, right, of the following. So now we're going to be using a Cartesian plane. So first we're going to draw the Cartesian plane, which when you draw the Cartesian plane, it's going to be like this, right? Then we're going to say all students take coffee, right? So when we say all students take coffee, now we need to first ask ourselves the fact that where is sign, because of that's the information that we're given, right? Where is sign positive? Because of why are we looking for sign that it's positive? Because we see the fact that 3/5 is positive, right? So we're going to ask ourselves where is sign positive? We see that sign is positive in the first and second quadrant, right? But when we're using the Cartesian plane, it's very important for us to know the fact that we cannot draw the triangle in both quadrants. We need to draw it at only one quadrant, right? So the second part of the information is going to help us determine to basically pick between the two which one we're going to use, right? They very tell us the fact that cos A is less than 0. What does it mean when cos A is less than 0? Meaning when cos A is negative. This is what it what you call this translate to, right? So now we're going to ask ourselves, where is cos negative? Cos is negative in the second quadrant, right? And also it's negative in the third quadrant, right? So with that said, what you call this, what quadrant are we going to draw the triangle? We're going to draw it on the second quadrant. Does that make sense? Why are we drawing it on the third quadrant? Because of on the second quadrant, because of on the second quadrant, sine is positive and also cos is negative. Does that make sense, guys?
Yes, ma'am.
Yeah, so we're going to draw the triangle. So you're going to draw a line. Then also always the dotted line touches the what? The x-axis, right? Then you're going to draw this. And this angle here is going to be the A. That's going to be the A, right? So from the information that they gave us, they say the fact that sine is equals to what? To 3/5. So 3, we know the fact that sine, right? A, in terms of if we didn't have values, is basically opposite over hypotenuse, right? So what is opposite? Opposite is the one that's opposite to the angle, which is this one's going to be opposite, right? Hypotenuse is going to be what? It's going to be the one that's opposite to the square, which is the 90 degrees. So this is going to be the hypotenuse, right? So now we know the fact that from our information, it's going to be the following. So, sorry. So from that said, right, it's going to be opposite, which is going to be this value here is going to be 3, and this is going to be 5, right? And it's very important to always complete the entire triangle, right? With our case is that what we're missing, we have this side, which is this one is parallel to the y-axis. So we have the y value, then we have r, right? Then we are left with x. So using theorem of Pythagoras, we can solve for what? We can solve for x, right? So we know the fact that the formula for theorem of Pythagoras when we use in the Cartesian, it's basically going to be r squared is equals to x squared plus y squared, right? R squared is going to be 5, so it's going to be 5 all squared is equals to what? Is equals to x squared, which is what we're looking for. So it's going to be x plus, then this is going to be 3 squared. Is everyone okay with that?
Yes, ma'am.
Yes. So this is going to be 25, right? So this is going to be 25 is equals to what? To x squared, right? Plus 9, right? So now when we say 25, which was 25 is equals to x squared plus 9. We're going to take the 25 to the other side. So it's going to be 25 is equals to what? It's going to be equals to 25 minus 9 is equals to x squared, right? And therefore, this is going to give us what? This is going to give us 16 is equals to x squared. Square root both sides. So that's going to be plus or minus 4 is equals to x. Reason why it's plus or minus, when you square root the both side, it's going to give you two answers, which is one is positive and one is negative, right? Only, very important, only r squared takes the positive, but with x and y, you need to basically say either one is positive and either one is negative. And looking from our diagram, we can determine whether we're going to use positive or negative. Do you see the fact that this x-axis, right, is on the negative side? So therefore, that means the fact that x is equals to what? Is equals to -4. Does that make sense? Why x is equals to -4 and not +4?
Yes, ma'am.
So that's how it is, right? So we know the fact that this is going to be equals to -4. So that's how you would complete the entire diagram. So now when you're done completing the entire diagram, you can start answering the questions, right? So with 8.1.1, right, it says we need to calculate sine than -a, right? So with this one, it's very simple. Everything is in terms of sine. So we need to get rid of this negative. So the following rules, right, is that sine of a negative angle, right? And let me say cos of a negative angle and also 10 of a negative angle. Let me just give you a couple of notes. This one and this one are always going to be negative. So this is going to be the sine of the angle, and this one's going to be negative cos 10 of the angle. Only cos becomes positive. Does that make sense? Does that make sense?
Yes, ma'am.
Yes. So just remember those three. And only sine and 10 becomes negative, but cos always becomes positive, even if the angle inside is what? Is negative. So with that said, we know the fact that this is going to be equals to negative sine A. And we already know the fact that sine A is 3 over 5, sorry. So this is going to be negative 3 over 5. So that's how that is, right? So now we're going to move to 8.1.2, which is 10A. So now we're going to use the diagram, right? 10A is going to be equals to what? Remember the fact that 10A is equals to adjacent. It's opposite over adjacent, right? So we know the fact that opposite over adjacent, we need opposite. Opposite is 3. And adjacent is negative 4. And that's going to be, your answer is going to be 3 over 4. Does that make sense? Negative 3 over 4. Does it make sense?
Yes, ma'am.
Any questions? Any questions?
No, ma'am.
No, ma'am.
Okay, cool. So now we can move on to the next question, right? So with this question, it says if cos 32 is equals to P, then they say, without a use of a calculator, right, write down the following in terms of P. Right? So with this one, again, I love using the Cartesian plane, right? But in this case is that our, what you call this, our angle is the one that's like given, but the other one is variables, right? Always write down the Cartesian plane, and within the triangle, fill in all the angles, because of probably one of the angles might be asked, right? So we have the following is that we see the fact that cos 32 is equals to P. Then they say without a use of a calculator. So we're going to have this, right? So, right? So we know the fact that this is going to be all students take coffee. So from this, we see the fact that we have cos 32 is equals to P. P is equals to what? P is positive. So we're going to ask ourselves, where is cos positive? Cos is positive in the first, right? And in the fourth quadrant. Everyone agrees with me, right? Does everyone agree with me?
Yes, ma'am.
Yes. Then now, remember the fact that we need to reduce it to which quadrant, because we can't draw the triangle in both the quadrant. So now we ask ourselves, how do we know which quadrant to use? They tell us the fact that cos 34, meaning the angle, right, needs to be, the angle here needs to be between what? Between 0 and 90 degrees. Do you guys agree? 34 is between 0 and 90 degrees, meaning it's going to be in the first quadrant. Does that make sense why we picked the first quadrant and not the fourth quadrant where our triangle is going to be?
Yes, ma'am.
Yes, so you're going to draw dotted lines. And this is going to be 90 degrees. This is going to be 34 degrees. The nice thing, since we already have this is 34. Do you agree the fact that we can find this angle here? Which is, we're going to use sum of angles on a triangle. Do you guys agree that with that? Because we know
Yes,
that,
ma'am.
yes, so it's going to be what? So it's going to be, so to find this angle here, it's going to be what? It's going to be, sorry. It's going to be 180 minus, then we're going to take out the 90 degrees because it's a right angle triangle. We're also going to take out the 34, right? So we're going to find that our angle is going to be equals to what? 180 minus what? Minus 90 minus 34, which is going to be 56. Do you see the nice thing about doing it in the Cartesian? Do you see the fact that now this is related to this? So one of the solutions is there. Does that make sense?
Yes, ma'am.
So now with that said, let's fill in the diagram, right? So remember the fact that when we fill the diagram, the information that they told us is cos 34, meaning this is going to be our reference angle, not the 56, but this one that is by the corner of the center is going to be our reference angle, right? So we know the fact that cos is what is adjacent. So adjacent is going to be here. So it's going to be P, right? And this is the same as divided by 1, right? So it's going to be P. So it's adjacent, right? You remember the fact that cos, right? Cos theta is equals to adjacent over hypotenuse, right? And our hypotenuse right now is going to be, and this is going to be P divided by 1. Is everyone okay with that? So the hypotenuse is going to be 1. Is everyone okay with that? With P and 1 in the position that they're in.
Yes, ma'am.
Yes. So now we're going to have to find our Y, right? And using the, what you call this, the, using the Pythagoras, is going to be r squared is equals to x squared. Remember the fact that this side is going to be y because it's parallel to the y-axis, right? Plus y squared, right? So let's fill in so we can have the entire diagram filled in. So this is going to be 1 squared is equals to p squared plus y squared, right? So this is going to be 1 minus p squared is equals to what? To y squared. So this is going to be plus or minus square root of 1 minus p squared is equals to y. Now we need to check where y is. Y is in the positive side. So therefore, we see the fact that y is equals to positive square root 1 minus p squared. So this is going to be what? Square root 1 minus p squared. Is everyone okay with that?
Yes, ma'am.
Yes. So now since we have the diagram filled in, let's answer the questions, right? So the first one says the fact that, so this is going to be 8.2.1. So with this question, it's going to be a mix of your identity and also mix of the actual Cartesian, or what you call this, the actual triangle that we just sketched, right? So with this one is that it says cos 214, right? So to check this one is that what you can do is that we can check the fact that can we use reduction. If we can't use reduction, we're going to ask our second question, can we use our identity? Meaning summing up two angles to get maybe summing up two angles, and those angles, maybe they sum up to 34. Can we use that? If we can't use that, we can also try to use what? The double angle. Does it make sense? So with the first one, let's check whether we can divide the 214 by 2. We see the fact that 214 by 2 gives us 107. That does not give us 34. So we're not close by, right? So now let's try reduction, right? So reduction, if I say 180 minus 214, what do I get? I get, if I say 180 minus 214, what do I get? I'm going to get negative 34. Right? So meaning I can use what? Meaning I can actually use reduction, right? I can reuse reduction, and by using reduction is the following, is that if I say now replace this 214 by what? We know the following. Let me just do this, right? Since this 2, when we subtract it, gives us a negative 34. That means if I say 180 plus 34, do you agree with the fact that 180 plus 34 is going to give me 214, which goes back to this? So do you see the fact that I can replace this 214 by 180 plus 34, which is great because if I'm going to go back to this one, does that make sense?
Yes, ma'am.
Yes. So I'm going to say what? I'm going to say now cos
Yes, ma'am.
is going to be replaced by what? By 180 plus 34, right? And now we're going to use reduction. So because my diagram of reduction is here, let me just show you on how to recreate it on your own, right? So with reduction is that you're going to draw your Cartesian on your side like this, and you're going to put your angle. So this is 0 and this is 36. So this is 0, this is 90, this is 180, right? And this is 270. Okay? Then now what we're going to need to do is that we need to create those things, right? So it's going to be all students first take coffee, right? And we know the fact that from this direction, this is going to be what? This is going to be 360, right? This is going to be 360 plus theta, right? And the bottom is going to be 360 minus theta. The 360 plus theta can also be replaced by what? By just theta. Hope that makes sense, okay? Then also here by the 90, by the co-function, right? Is that this side, when you're going this side, you're going backwards. So this is going to be the same as 90 minus theta. But when you're going in this direction, we're adding, right? So it's going to be 90 plus theta, right? So we're done with that. And now going here, when you're going in the other direction, this is going to be 180 minus theta. But going in the other direction, it's adding up. So it's 80 plus theta, right? So the 270 is going to be what? It's going to be 270, right? Minus theta. Then this is going to be 270 plus theta. 270 and 90 are cofunctions, meaning changes your cos and your sine to, like, if you have a sine 90 something, right, that changes to cos. And if you have a cos like that is like 90 by something, right, that changes to a sine. Does that make sense?
Yes, ma'am.
Okay, cool. So with that said, now is that our 180 minus 180 plus 35, this 35 in this diagram is represented by theta, right? So we're looking for 180 plus theta here. So we see the fact that 180 plus theta is in here, and we see the fact that only 10 is positive. So your answer here is going to be the same as negative cos 34. Is everyone okay with that?
Yes, ma'am.
So this is going to be the same as what? As negative. Remember the fact that cos 34 degrees is P. So this is going to be negative P. And that's going to be your answer for that question. Okay? So I hope that makes sense. Now we're going to move to 8.2.2, right? We have cos 68. We see the fact that if I say 68 multiplied by 2, I'm going to get what? I'm going to get 34. So we see the fact that if I say 34 multiplied by 2 is going to give me 68. Why is this important? This one is important because we can use this, right? We can use this property. We can use this property, right? So since we know the fact that we can use this, so we can replace what? We can replace the 68 by 2 multiplied by 34, right? So we can, for this one, it's going to be cos, right? And it's going to be what? 2 multiplied by 34 degrees, right? Which is the same as saying cos, right? Cos, and I'm just gonna take out this, that this is the 2, and this is gonna be the 34. So in our case here, remember the fact that we want anything that is related to 34. This is great because of now this angle here, right? This 34 is going to be taken as our theta in our case. So now when we're substituting, we can replace this theta by this 34, which is great because of now everything becomes simple, right? With that said, is that we see the fact that cos, what you call this, our question is telling us the fact that cos 34 is equals to P, and we need to write everything in terms of P, right? So we have to use this one, because remember the fact that for double angle, cos has 3 options. We're going to use the one that has only cos because of in our question, the information that's required is the one that has cos only. Does that make sense? Why we can't use the one with sine? Why we can't use the first one because it has sine, and why we can use the second one because it has cos? Doesn't make, because it has sine too. Does that make sense?
Yes, ma'am.
Yes, ma'am.
Yes. So now with that said, remember the fact that now our 34 is going to be our theta, right? So this is going to be the same as what? As saying 2 cos squared, right? 2 cos squared, then you're going to say what? You're going to say 34 degrees minus 1, right? So now this is the same as saying 2, then open bracket, this is going to be cos 34 all squared minus 1. What do we know? We know the fact that cos 34 degrees is equals to P. So this is going to be the same as 2P minus 1. 2P squared minus 1. Does that make sense?
Yes, ma'am.
Yes. So that's how you answer that. Now let me erase this diagram and answer the last question. So now answering the last question, which is going to be 8.2.3, right? It says the fact that we need to find 1056. With 1056, right, is that we can use this identity property, which is 10 is equals to sine x divided by cos x. But with that said, is that how, when using that, right, is that using co-function, because of, if you say 90, let me just show you. If you say 90 minus 56, right? Right? If you say 90 minus 56, you are going to get 34, right? Which is great. But the problem is when you're using this, is that when you're using the identity, right? You can still solve it using the identity by using this identity, right? Here at top is going to be 90, right? 90 minus 50 and 90 plus, sorry, 90 plus 34. And also at the bottom is going to be the same thing. But the problem is that this one is going to change to cos, which is what we want. And the other one is going to change to sine, which is what we don't want, right? So to not complicate things, right, is that we can just use this information. We can just use this whole triangle to find our answer. Even if we do it like, or should I do it in both ways? Because if I can still do it in using the identity and using this, should I do it in both ways so that you guys can see how to do it? Because I can still use this identity to solve this question. Should I do it in both ways?
Yes, ma'am.
Okay, cool. So let's do it in case number one. Case number one, I think, is the simple one, right? So case number one is using our triangle to solve it. But now, instead of using 34 as our reference angle, because if we have 1056, we're going to use the 56 here. We're going to use this part here as our reference angle, right? So meaning this is going to be my opposite. This P here is going to be my opposite. And this what? This what you call this one P minus, what you call this, a square root of 1 minus P squared is going to be what? It's going to be my adjacent, right? Hope that makes sense. We just change our reference angle to this being this 56, but still use the information that we given. Does it make sense?
Yes, ma'am.
Yes. So with that one is that we know the fact that that's going to be equals to what? It's going to be equals to opposite over adjacent, right? What is opposite? Opposite here from the yellow one is going to be P, right? Then adjacent is going to be what? It's going to be this one, which is going to be square root of 1 minus P squared. That's fine, right? Now, using the second case, and I'm just going to do it in this portion here in red so you can see it, right? So using the second case, we know the fact that 1056, right, can be written as, remember I said the fact that if I add this, so if I say 90 plus 30, what you call this? If I say 90 minus, sorry. Here, if I say 90 to get 56, right? So if I say 90 minus what? Minus 56, I'm going to get 34, which is great, right? So now if I say what? 90 what? 90 minus now, because I want 56. If I say 90 minus 34, I'm going to get 56, right? So do you agree the fact that this can be changed into being what? Into being 90 minus 34, which is going to be equals to 56. Does that make sense? So this is going to be changed with that, which is going to be 90 minus 34, right? So the nice thing with this one is that we cannot use cofunction with 10, right? But we can use cofunction with sine. But how can we use the sine? Is using this identity. So when using this identity, this is going to be the same as saying sine 90 minus 34, right? Divided by what? By cos. Then it's going to be 90 minus 34, right? So I'm just going to use this one, right? I'm just going to use this reduction so that you can see what am I doing, right? So where is 90 minus, right? Do you see the fact that 90 minus is in the first quadrant? Is this true? So 90 minus theta becomes cos. This cos 90 minus becomes sine, right? So they're just going to change. So this is going to be what? This is going to be the same as cos 34. Is everyone okay? Why is it cos 34? Because it's a cofunction. Is everyone okay with that?
Yes, ma'am.
Then the other one is going to be what? It's going to be sine 34, right? So now, simplifying this, we already know the fact that cos 34 is equals to P, so that's great, right? Now we need to solve for sine, right? Sine what? Sine 34. So now in sine 34, we're going to use this 34 as the reference. What sine? Sine is opposite over hypotenuse, right? So this is going to be opposite, which is square root of 1 minus p squared, right, over hypotenuse, which is 1, which is, this is going to be the same as 1 minus p squared. So do you agree the fact that this sine is basically equals to square root of 1 minus p squared? Is everyone okay with that?
Yes, ma'am.
So do you see the fact that you can use either or, you're still going to arrive into the same answer?
Yes, ma'am.
Okay, cool. So that's how you would answer this question. So now we're going to move to this question here. Let me just do this one. Do you see the fact that with this one is that it's going to, what you call this? It's going to apply your what? It's going to apply your reduction, and also it's going to apply your reduction first, and after that it's going to apply this identity. One of these identities is going to be applied here. Do you see that? Do you guys see that? Because of the double cos sine is that one of the identity, one of these ones is going to be applied here. Does that make sense?
Yes, ma'am.
Yes. So they say without using a calculator, determine the value of the expression. When they say without using the, what you call this, without using a use of a calculator, and they give you variables, just know the fact that the following needs to happen. You need to use your special angles, right? What is your special angles? It's 0, it's 30, right? It's 30, it's 45, and it's 60. So just know the fact that these three are the ones that are important when we're dealing with special angles. The 0 and the 90 and the 360 really doesn't matter, but what matters is your 30, 45, and 60. So here, when we reduce it, we need to see either 30, 45, or 60, right? So that we can simplify it fully. Does it make sense?
Yes, ma'am.
Okay. So now let's take the question. So we know the fact that we're going to have the following. We're going to have cos, right? Then cos is going to be 350. Then it's going to be sine 40, right? And this is going to be minus cos 440 degrees. And this is going to be cos 40. So what do we see? We see the fact that we have two things that matches up with angles, right? So those two, we're going to leave them. So we see that this one matches up with this one, right? Meaning one of these identities is going to play a role. So we're going to leave this 40 when we're reducing, right? Now we have to deal with this two. Does that make sense? We need to deal with this 350, and we also need to deal with this 440, right? So let's start with what? Let's start with this 350. So when you say 360 minus 350, what do you get? We get 10, right? So we see the fact that now if I say cos, so this, if I say the first one, cos is equals to 360 minus 10, that makes sense, right? Because of, if I say 360 minus 10, I'm going to go back to 350. Does everyone agree with me?
Yes, ma'am.
And we're going to leave this alone, the sine 40, right? Then now we're going to deal with this. If something is greater than what you call this 360, right, is that we're going to reduce it. If something is greater than 360, we're just going to subtract 360 by it, right? And write the remaining angle. So if you say 440 minus 360, you're going to get 80, right? So you're just going to reduce that. So you're going to say this is going to be the same as cos 80 degrees, right? So whenever something is greater than 360, you just take that number subtracted by 360, and whatever that's left, you're just gonna rewrite the new number. Does that make sense? And this is gonna be cos 40 degrees. Does that make sense? How we got this 80. Does that make
Yes,
sense,
ma'am.
guys? Yes. So now we see the fact that here with this one, let's look at the diagram with 360 minus. 360 minus is here, right? So sine is negative. So we see the fact that here sine is going to be what? It's going to be negative. So here it's going to be 360 minus 10 degrees. So it's going to be sine is negative. So it's going to be minus sine So it's going to be minus sine. So it's going to be minus, oh, sorry. We see that cos is positive. I'm sorry, we're looking for cos. Sorry, so it's going to be cos is positive. So it's going to be cos 10 degrees, right? And this is going to be sine 40 degrees, right? Then we just reduce this one, this cos, this one, then this one, right? What do we see? We see the fact that our first portion, right, is what? Is, let me just write cos so that I can show you guys. And this is going to be cos 40 degrees, right? So we see the fact that, let's go back to the identities, right? We see the fact that for cos, for the identity to work, this is the following. It needs to say cos, right? So here we don't have cos. We have cosine. Which one matches up with cosine? Do you see the fact that the sine one matches up with cosine? Do you see that? Do you see the fact that we have sine and cos, and one is 10 and one is, what you call this, one is 40 degrees. And this side we have what? We have just cos, but we don't have sine. But what do we know? We know the fact that we can change a cos to a sine by using cofunction. And what do we see? We see the fact that if we say 90 minus 80, we're going to get 10 degrees. Do you guys see that? If we say 90 minus 80, it's going to give me 10 degrees. So I can replace this 80 by what? By saying 90 minus 10, right? And this is a cofunction. Do you guys see that? So meaning this is going to change into sine, which is great because of in cos and sine is that with this identity, you need one to be a cos and one to be a sine. Does that make sense? When we expand it, does that make sense?
Yes, ma'am.
Yeah, so that's what we're going to do. So we're going to, this one remains the same. So this is going to be cos 10 degrees. And this is going to be sine 40 degrees, right? And this is going to be minus. Now we're going to change this 90. So it's going to be cos. Then it's going to be 90 minus 10. And why is this great? Because we know the fact that the angle is going to share this angle with this one, which is what we want, right? So there's going to be cos 40 degrees, right? So now let's reduce this, where is 90 minus is in the first quadrant. So this is going to be what? This is going to be positive. So this is going to be equals to cos 10 degrees sine 40. Then this is going to be what? A positive sign. So it's going to be minus sine. Then this is going to be what? This is going to be 10 degrees. And this is going to be cos 40 degrees. So that you can see it properly, let's rearrange it the way it's written, right? Let's start with sine. So this is going to be the same as having sine 40 degrees, right? Multiplied by cos 10 degrees. Then this is going to be minus starting with cos. So it's going to be cos. Because with multiplication, you can interchange them, right? So it's going to be 40 degrees. Then this is going to be multiplied by sine 10 degrees. Is everyone okay with that?
Yes, ma'am.
Yes. Do you see the fact that that one matches up with what? We see the fact that this identity matches up with this one. Right? See sine cos minus cosine, which is great. So we're going to change it with this one. We're going to move it with this one, where 40 is our A and our B is 10. So this is going to be the same as sine, and this is going to be 40 minus 10. Which is 40 minus 10 gives us 30. So it's going to be sine 30 degrees, which is great, which is one of our identity. And now when we punch that into the calculator, you find the fact that our answer is a half. Is everyone okay with that?
Yes, ma'am.
So that's how you would do this question. Hope everyone understands. Any questions before we move to the next question?
No, ma'am.
Okay. So now we're going to move to the next question. So the next question, as you can see, the fact that it's related to a graph. So we're going to first start talking about the basic parts that you need to know about a graph. Then we can go to answering the actual question. Anna? So the first thing that we need to know is that what does A do? What does B do? What does P do? And what does Q do? Like, let's do a quick rundown. We know the fact that A, it gives us the amplitude, right? So let's just draw the sine graph. A gives us the amplitude. So the amplitude is here, right? So this point, this is what A gives us, right? And also it gives us the amplitude. So that's the first part. So it tells us how tall or how short the graph is. Right? Then A, if A is positive, this is how the graph is going to look. But this is when A is greater than 0. But when A is negative, our graph is just going to flip on the other side, meaning the maximum becomes the minimum and the minimum becomes the maximum. Does that make sense? So it's going to look like this. So your maximum and minimum points are going to interchange. Does that make sense, guys?
Yes, ma'am.
Okay, so that's what A does. It gives us the amplitude, and also it gives us what the maximum is going to, what you call this, when it's positive, your maximum becomes your maximum is going to be the normal mother graph. But when it's negative, is that they interchange. Your maximum becomes your minimum, and your minimum becomes your maximum. Hope that makes sense. Now, B, right? B is the frequency factor. So B gives us the frequency, right? So let me just go up. B is going to give us the frequency, right? That's very important. So you know the fact that with sine and cos, our period, so our period is going to be what? Is going to be equals to 360. So with B, it gives us, if B is any number, if you want to find the period of that function, is that you just divide it by B, right? And that's going to give us your period. Does that make sense? So B gives us what? Gives us the period. So that's the role that it plays. Is everyone okay with that?
Yes, ma'am.
Yes. Then P with all graph is that P moves the graph left or right, right? That is called the horizontal shift. It just moves our graph on the left side or on the right side, right? And remember that with P is that the answer that's inside the formula when you take it out is not the same, right? So whatever you have in the formula, when you finding that value outside, it's just going to be the opposite of it, right? Hope that makes sense. Or should I explain it a little bit more?
No, ma'am.
Okay, cool. Then we're going to move to Q. Q moves the graph up or down, right? So Q moves the graph up or down. And with P, what I just said, it does say it here. If P is greater than 0, meaning when P is positive, right, our graph moves to the right, right? Which is the right is going to be the right-hand side. Then when P is less than 0, then P moves to the left-hand side, right? It does say it there. Then the last one, which is our Q, it moves the graph up or down. And that one maintains its sign, meaning if it's positive, it's going to move up. But if it's negative, it's going to move down. Hope that makes sense. Is everyone okay with this cute rundown of the
Yes, ma'am.
properties of the graph? Okay. So now we're going to move to the properties of cos, right? So again, A, B, C, I'm saying A, B, C, D, but A, B, P, and Q, they share the same properties, right? It's just that the only difference here is that the shape. But how A behaves, it behaves similar to how it behaves in sine. So the only thing here is going to be the shape, right? So here the shape, it's like this, right? So meaning this is when A is greater than 0. And remember the fact that your maximum becomes your minimum and your minimum becomes your maximum. So here it's going to look like this. So this is when A is less than 0. Does that make sense? But everything that we said about sine is exactly the same thing with this one too. Is everyone okay with that?
Yes, ma'am.
Okay, cool. So now we can move on to answering the actual questions. So the first, it says, let's read the information of the question, right? It says the graph of f of x, right? So I like highlighting my f of x and g of x, right? So that I can know who I'm talking about. So they tell us the fact that f of x is equals to cos, open bracket, then they say x minus 45. So do you see the fact that the graph cos moved 45 degrees to the what? To the right, right? So with this one is that it moves 45 degrees to the right. So let's highlight it. So this is going to be sine f of x is going to be this one. So that's going to be f of x. So f of x is going to be the one in yellow. Let me just highlight it in yellow so we can see who is who, right? And they tell us the fact that g of x, which is going to be equals to negative 2x, right? So negative 2 sine x, right? So it's going to be this one. right? So they tell us a sketch below between the range. So it's between negative 180 and what you call this, and 180. And they tell us that the point T is the x-axis. So we see the fact that the point T here, you take my pen, this point here is the x-axis of what? Of a function f, which is the yellow one, as indicated in the diagram. Is everyone fine so far?
Yes, ma'am.
Okay, cool. So now we're going to move into the first question, which is 9.1. 9.1 point. So it's going to be just 9.1, right? So they say the fact they showed that cos x minus 45 is equals to negative 2 sine x, right? And they say the fact that can be written as 10x is equals to negative 0.2612, right? So we see the fact that we have cos, I'm sorry, let me write it below. Okay, 9.1. Because the drop down keeps on going down. So cos then it's going to be x minus 45 is equals to negative 2 sine x. Very important, I'm going to say something, is that you see the fact that cos x minus 45, that is f of x, right? And this is g of x. Do you see the fact that they're basically asking us to find the intersection? You guys see that?
Yes,
We're
ma'am.
simplifying it, yes. So very important to always link to which like information that they want us to do, because of maybe us, like them asking us for intersection, it's going to help us maybe in the next question, right? So always see the relationships, Anna. So we see the fact that here we can use what this identity. I don't know why I don't have it here, but we can use this identity, right? Let me just do this. Yep. I want to copy that identity table. Okay. Okay, so we see the fact that here for this cos x minus 45, right? What can we use? We can use the identity, right? The identity that we're going to use is this one, because we can reduce it. And what is the nice thing is that 45 is a special angle, right? So we can basically, the other ones are going to be actual values, right? So we can use this identity. Do you see that? You guys see that?
Yes, ma'am.
So that's going to be that. So this is going to be replaced by that. So my pen color. So this is going to be equals to what? This is going to be the same as saying cos x, right? Then cos 45, right? And it says plus here because it's negative. So it's going to be plus, then this is going to be sine x, then this is going to be sine 45 is equals to negative 2 sine x, which is great. So now let's simplify this. Then cos 45, we know the fact that this is going to give us what? This is going to be cos x, and this, when you say cos 45, is going to be root 2 divided by 2, right? And this is going to be sine x. Then sine 45 is also going to give us what? Root 2 divided by 2 is equals to what? Is equals to negative sine, right? So now we see the fact that this two are the same thing, right? So we can group like terms. So these two are the same thing because of they both have sine what? Sine x, right? So we know the fact that this side is going to be the same as cos x. Just take the number in front. And this is going to be equals to the same as negative 2 sine x. And it's going to be minus what? Minus root 2 over 2. Then this is going to be sine x. Is everyone okay with what I did so far?
Yes, ma'am.
Yes. So now we're gonna basically, because of this is the same thing, we're just gonna add the numbers together, right? So when you say -2 minus, then you're gonna say √2 divided by what? By 2, right? That is gonna give you what? So you're gonna have, so it's gonna be √2, yeah, 2 cos x is equals to what? Here is gonna be, when we add this together in the calculator, not taking the sign into account, it's going to be -4 plus √2 divided by what? Divided by 2. Is everyone okay so far? And this is going to be, this negative is the whole fraction, so that you guys are not confused. Is everyone okay so far?
Yes, ma'am.
And this is going to be sine x. So remember the fact that in the equation, they said the fact that we need to, this can be written as 10x. What do we know about that? We know the fact that that is from the identity. What do we know? We know the fact that 10x can be written like this, right? So we can get rid of what? We can get rid of the sine and cos. So we're going to divide both sides by cos. So when we say that, so we're going to have √2 divided by 2. That dividing both sides, this one is going to cancel out, and this side is going to be negative. And this is going to be 4 plus √2 divided by 2. And this is going to be sine x divided by cos x. Is everyone okay with that?
Yes, ma'am.
Yes. And with that said, is that this is going to give us 10, right? So this is going to be √2 divided by 2 is equals to -4 plus √2 all divided by 4 divided by 2. And this is going to be 10x. So now we want 10x alone. So this is going to be the same as saying √2 divided by 2, right? And this is, I'm going to say division like this. And this is going to be minus, then this is going to be 4 plus √2 divided by 2. It's going to be equals to 10x. Let me just move it here. Now, when you say 10x, it's going to be equals to, when you take your calculator and say √2 divided by 2, right? And this is going to be division minus, then it's going to be a fraction. When you say 4 plus √2 divided by 2, you're going to get that your answer is going to be whatever that they want, which is going to be exactly as -0,2612, which is, you've proven the first part. Is everyone okay with that? Yes?
Can you please repeat how we got -4 plus √2 over 2?
Yeah, this one. Okay, let me show you in the calculator. Should I show you guys on the calculator? Let me show you
Yes, ma'am.
guys. Okay, cool. So let me do this. Okay, sure. Delete. Okay. So now, do you see the fact that, okay, wait, let me take my highlighter. Right? Do you see the fact that this sign, right? This sign x is taken like as like, do you see the fact that if you had 2x plus 3x, when you punch those numbers in the calculator, you don't punch in the x, right? You just punch in the numbers. Do you agree with me?
Yes, ma'am.
So that's what we're going to do. So we're just going to punch the numbers. What is the numbers in front of them? Because of they are all common, right? The number in front of them is -2. So you're going to say -2. So you're going to take this negative, right? My Kesha is acting. Let's delete it. Okay, well, let's wait for it to stop acting. Okay. Let me call it again. Okay, sure. So what you're going to do is the following. As I said, you're going to say negative. Why doesn't it want to? Okay, let's delete it again. I think my pen is the problem. Let me not choose my pen. Okay, sure. Let's pray that it works, right? So if you say negative, yes. So if you say -2, right, then the other one is negative square root of 2. So you're going to say minus, then you're going to say this, then you're going to say √2, right? go down. So you're going to say root 2. That is going to give you, do you see? It's going to give you negative 4 plus root 2 divided by 2. Do you see that?
Oh, yes, I see, ma'am.
Yes. And now let me just do the final one where we got this decimal. Is that with that one, let me just delete everything, right? I just said, took my root 2, because that's what we have. So it was root 2, right? Then that divided by 2. Then I don't want to use this fraction, like putting in fraction, because we already have too many fraction. Then I say divided by, then you're going to say negative. Using that, then you're going to have what? You're going to have 4 plus root 2. So it's 4 plus root 2, right? And that's going to be divided by 2. And you'll see the fact that this is what you're going to get. To get it to decimal, you're going to press ST. Then do you see the fact that that's exactly what they want? You guys see that? Can you guys see that?
Yes, ma'am.
Okay, cool.
Yes, ma'am.
So that's how you will do it. So now, because I need this.
Ma'am,
Yes?
you could also solve it uh, similar to each general solution, similar to how you would solve each general solution,
No,
this
because
question, and get the
technically,
reference angle.
no, we not asking. They didn't ask for the reference angle. The second question asked for the reference angle. So they didn't ask you for the reference angle here. They just want you to simplify it, showing the fact that cos, let me do this. When I discuss it, we can, because I need space. Okay. Let me erase this, then I'll answer you properly. Anna. And this one too. Let's erase you. Okay, so let's go to the question, right? So in this question, they say the fact that we need to show it's the same as, do you see the fact that in questions? Yeah, this is the same as they say in the fact that proving, like prove that this whole thing is equals to 10. So that's the same thing. But in this case, they say show. Does that make sense? So we're not proving general solution. They didn't say solve the equation. But with the second one, they say solve the equation, which is this is the case. Does that make sense? Hello?
Yes, ma'am.
Yes. So here they just wanted you to simplify the cos x minus 45 equals to 2 sine into being in terms of 10x is equals to negative 0.2612. So that's that. So you just needed to simplify it, simplifying the equation into a single trig ratio. They just made it in terms of like graph. They asked that question in graphs. Does that make sense though?
Yes, ma'am.
Okay, cool. Hope that makes sense. So now let's move to the second question. It says we need to do what? Okay. It says solve the equation cos x minus 45 is equals to negative 2x squared, for which your answer needs to be, your x value needs to be between negative 80 and 180, right? So with that said, do you see the fact that we already reduced this? We already know that we already know, so this is 9.2, 9.2. We already know the fact that cos x minus 45, right, equals to negative 2 sine x. We already know that this is the same as what? As 10, right? 10x is equals to what? To negative 0.2612. You guys agree the fact that we already reduced it into this 10, right?
Yes, ma'am.
Yes, from this, that it's very easy. We're just going to use what you call this. We're just going to solve for our general solution, right? So with our general solution is that from the Cartesian, remember the fact that we need the reference angle, right? So first step, we need a reference angle. So the reference angle is basically going to be what? Arc 10, right? arctan of what? Of this value. But remember, the value that we're going to put here is not going to be the negative one, but just the positive one, right? Because this angle, the sign here tells us which quadrant is our, which quadrant our solution is going to be in. Does that make sense? So this is going to be 0.2612. So when you find the reference angle, it's going to be arctan, right? So it's going to be arctan of 0.2612, right? Which is going to give you 14. So your reference angle is going to be 14, 14,664. Is everyone okay with the reference angle?
Yes, ma'am.
So now, after finding the reference angle, is that we need to know which Cartesian planes, right? Where is our solution going to lie? So the first thing is that we're going to have what? This is going to be 0, this is going to be 90, this is going to be 180, this is going to be 270, and this is going to be 360, right? So now we know the fact that our 10, very important, our 10 is negative. So where is 10 negative? So remember, this is all students take coffee. So where is our 10 negative? It's in the second quadrant, and also where it's in this quadrant, which is this one. Going to be in our fourth quadrant, right? That's where our 10 is negative. But very important, this thing has a restriction, right? It is a restriction in a sense of they tell us the fact that our answer needs to lie between negative 180 and 180, right? So our answer needs to lie between negative 180 and 80. So our answer needs to lie between these two. So it's going to be negative 180. So it's going to be from here, the negative side of it and the positive side. So in our case, this is going to be, we're going to look at the positive side, because in our Cartesian, we have the positive side. It's between 0, do you see? 0 is here, and 180. So our answer needs to lie in this second quadrant only. We cannot consider this one because of this one is between what? It's between 180 and 360, and that's not part of our restriction. Does that make sense?
Yes, ma'am.
Yes. So with that said, is that our answer needs to lie here, which is going to be what? 180, 180 minus the reference angle. So that you guys are not confused, right? So with that said, we know the fact that x, right, it's going to be x is going to be equals to 180 minus what? The reference angle, which is 14,64, right? And you're going to say plus what? Plus, since this is 10, our period is what? Is 180. So it's going to be 180 degrees, right? Multiplied by k. Is everyone fine with that? And remember the fact that k is an element of what? Of integers. Is everyone okay with that so far?
Yes, ma'am.
So now simplify it. So it's going to be x is equals to, when you say 180 minus 14,64, it's going to give you what? It's going to give you 165. So it's going to give you 165, 36, right? Degrees. And this is going to be what? Plus 180 multiplied by k. And remember that k is an element of real numbers. So now, because of our restriction, again, we need to basically figure out the two values. Here, we cannot make it into a general sense. The reason why is that they gave us a restriction, the fact that it's between negative 180 and 180. So now we're going to do our trial and error by picking a k value, right? And check where it's going to lie, right? So we already have on the positive side, right? We're going to check whether when we substitute our k, and we're going to start at k is equals to, maybe let's start with k is equals to 4, right? And trickle down, right, to maybe k is equals to positive 4, right? And see the fact that within those values, when we substitute, are we going to get values that are between negative 180 and 80, right? So now for k, right, is equals to negative. Let's start with negative 2. Negative 4 is too far, right? So wherever we see k, we're going to substitute by that, right? So if we say x is equals to, then, so we're going to do plus and minus here. right? So this is going to be 165,36 plus 180. Then this is going to be multiplied by -2. We see the fact that our answer is going to be 165,36, right? Then plus 180 multiplied by -2. We get the fact that our answer is going to be equals to 194,64. Do you see the fact that 194 is not in between this? Do you see the fact that 194, it's outside? Do you guys see that? So
Yes, ma'am.
this cannot be the answer. And also, if you substitute now in the calculator, and let me just do it like this so I can be quicker, because it doesn't make sense to write everything down, right? Do you see the fact that we're going to do this? Let me do this, right? So we're going to write it. So it's going to be 165, right? Comma 36, right? And this is going to be plus 180, right? Then open bracket, it's going to be where you're going to find your K, right? We're going to start with -2. As we see that -2 gives us what? Gives us 198. It's not between -180 and 180, right? It's outside. So that one can't be our solution. But now if we move to -1, right, doing it like this in the calculator, we find the fact that our answer is -14, right? So we see the fact that -14 is between those two. Do you guys agree? So we see the fact that -14 is between those two. So we see the fact that, okay, now x is equals to -14, right? -14, 64. Is everyone okay with that?
Yes, ma'am.
Yes. Now, again, trial and error, we add -1. So now we're going to try 0, right? So now when we do 0, we see the fact that when we do 0, we're going to get a positive what? We're going to get a positive 165, right? So also, or we're going to have another value, which is x is equals to 165, 36, right? Then we're going to check again. After 0 comes what? Comes 1, right? So comes 1, positive 1. So we see the fact that after that, it's going to come 1, right? So we see the fact that we get 345. Then we know the fact that any number after 1, it's going to give us a bigger number. So this is going to be our two solution. It's going to be x is equals to -14, or, because it's only both of them, or it's going to be x is equals to 165, 36. Does that make sense?
Yes, ma'am.
Okay, so that's how you will do that question. I think we'll continue next week with the following questions. But any questions before we leave? Let me stop sharing. Any questions? Any question, guys?
Ma'am?
Yes.
What if our reference angle is 0?
Then
What do we do?
okay, let me share again. So that if our so if our reference angle is 0, is that, you see the fact that here we said 180 minus 14,64, then that 14,64 is going to be replaced by 0. So
Yes, sir.
meaning, yeah, so it's going to be 180 plus then 180k, where k is an element of real numbers. So here that 14, that is our reference angle. So whatever you get here is substituted here. Does it make sense?
Yes, ma'am. Yes.
Okay. Any questions before I unshare this? Any questions, anyone?
Okay, ma'am. When it's the error, when the calculator gives us an error,
Calculators gives you an error.
when we're trying to find either those reference angle.
Oh, what are you punching?
Just asking, Jen.
It will never give you an, oh, wait. You punched something wrong. You did something wrong.
No, I was just asking, Jay.
Yeah. No, just know if you do get that, my guy, it's over. Like try to resolve it again.
Okay.
Yeah, try to resolve it again because you shouldn't be getting an error. You should be getting actual values. Any questions, guys? Should I stop sharing the screen?
Yes, ma'am.
Okay. Any questions?
No, ma'am.
Okay.
No,
So,
ma'am.
so how is everything so far? Let me. Why can't I stop sharing? Okay. How's everything so far? Is it helping? Is the classes helping? Stop recording.
Yes, ma'am.
Okay. I'm glad. I'm glad they're helping. Okay, guys. I'll see you guys next week. I don't know what we're doing. I know I have a schedule, but I'll see you guys next week. But I think we kind of done with like the main topics, right? Looks like we're done with the main topic so far because we left with analytic, right? Yes, we left with analytic. We're actually done.